So now we are going to discuss another concept which is the convolution. Convolution we are going to discuss. So in the discrete time domain, the first thing in the discrete time domain, we are going to discuss the convolution. So this is the LTI system. LTI system is the system is going to satisfy the two properties. One is the linearity as well as the time invariant. So the system is going to satisfy the two properties, which are the linearity property and the time invariant property. So linearity means I already told you, which is the input is the summation of two previous inputs and the output is summation of the two previous outputs. Similarly, time invariant means if the input is delayed by some amount of time, the output is also delayed by same amount of time, then we can say that the system is said to time invariant. So whatever the system that we are going to take, it is going to satisfy the two properties which are the linearity and time invariant. So then we can say this is LTI systems. So for this LTI system, if the input is impulse signal delta of n, then its impulse response is h of n. So for this LTI system, I have given the delta of n as the input, and I am going to get the output as h of n. Well, the delta of n is called as the impulse signal, unit impulse signal, and the h of n is called as the impulse response or unit impulse response. You can call it anything. So delta of n is called as the unit impulse signal and h of n is called as the unit impulse response. So for this LTI system, if you are going to give the input as delta of n, and the output with the output we are going to get is the h of n. So delta of n is called as the unit impulse signal, and the output h of n is called as the unit impulse response. So for the same system, if I give the input as x of n, then the output is y of n. So we have to find some relation between these things, which is x of n. I can write like this: x of n is equal to sigma k is equal to minus m to plus m to d x of k into delta of n minus k. I can write x of n in the terms of this manner. So basically, because I already told you x of n, you can write in terms of delta, which is impulse signal, which is x of n is equal to sigma k is equal to minus m to plus m to d x of k into delta of n minus k. See, I already told you x of n is nothing but you can write in terms of impulse domain, and if you do it summarize, you can get like this: x of n is equal to sigma k is equal to minus m to plus m to x of k delta of n minus k. Then what is y of n? Y of n, if you simplify, we are going to get see x of n I have written like this: s of k into delta of n minus k. Summation of all these things, get the impulse signals. Then what is the output? Output is nothing but for each and every impulse. And what is the response that you are going to get for delta of n minus k? What is the response that you are going to get? H of n minus k. The scalar quantity is same, which is x of k. So we can say, as the system is going to satisfy the linear time invariant property, so therefore for delta of n, the output is h of n. For delta of n minus k, the output is h of n minus k, because it's going to satisfy the time invariant property. Then we got h of n minus k. As it is also going to satisfy the linearity, so input is multiplied by some scalar quantity, so output is also multiplied by the same amount of scalar quantity. So here the input is multiplied by x of k, so output is also multiplied by x of k. And linearity means the input summation of two previous inputs, the output is also summation of two previous outputs. So because of summation, we have same summation of the sigma. So y of n is equal to sigma k is equal to minus m to plus m k x of k into h of n minus k. So these things I have told in a very clear manner. So x of n is equal to sigma k is equal to minus m plus m to x of k into delta of n minus k. Then y of n is equal to sigma k is equal to minus m plus m to s of k into h of n minus k. So this I can write like this. So this is I can write like this: x of n convolution of h of n, or you can write vice versa also, which is h of n convolution of x of n also. You can write like that. So therefore we can say, what is the y of n? Y of n is equal to x of n convolution of h of n. So y of n is equal to x of n convolution of h of n, and the equation is sigma k is equal to minus m to plus m to x of k into h of n minus k. So this is a thing always you have to keep in mind. So finally I can say, which is x of n is equal to sigma k is equal to minus m to plus m to s of k into delta of n minus k. Then y of n is equal to sigma k is equal to minus m to plus m to s of k into h of n minus k. You can write like this: just shortcut x of n convolution of x of n convolution of h of n, you can write, or you can write like this: h of n convolution x of n is also equivalent, because the function is going to satisfy the completive property. So these things always you have to keep in mind. So finally I can say that y of n is x of n convolution of h of n, which is equal to sigma k is equal to minus m plus m to s of k into h of n minus k. So these things always you have to keep in your mind. So now let's go for the continuous time. So up to now we have discussed the convolution of discrete time domain. Now let's go for the continuous time domain and see what are the things are going to happen. So for the LTI system, if the input is delta of t, the output is h of t. So delta of t is called as a unit impulse signal, and h of t is called as a unit impulse response. So listen carefully. The delta of t is called as a unit impulse signal, and h of t is called as a unit impulse response. So for this LTI system, this is going to satisfy the two properties, linearity and the time invariant. So as the system is going to satisfy the two properties, linearity and time invariant, that is the reason it is called as a linear time invariant system. So for the input delta of t, we are going to get the output h of t. So delta of t is called as a unit impulse signal, and h of t is called as a unit impulse response. Suppose I am going to use some input x of t, then the output I am going to get y of t. So now I need to find some relation. So I have already told x of t. Here we can write like this: x of t is equal to integration from y is equal to minus m to plus m to t x of tau into delta of t minus tau d2. So you can write like this. Here this m means here you can write in terms of like this you can write. So the summation means it will become integration. So in a discrete domain, the sigma will become an integration of the continuous time domain. So x of t is equal to integration from tau is equal to minus m to tau is equal to plus m to x of tau delta of t minus tau into d tau. Then what is y of t? As I already told you, for delta of t the output is h of t. Then for delta of t minus tau the output is h of t minus tau. Input is same as a scalar as a should be. So because of linearity property, if the input is multiplied by some scalar quantity, the output is also multiplied by the same amount of scalar quantity. So because of summation, because I've already told in the linearity, the input summation of two previous inputs, the output is also summation of two previous outputs. So because of that, we have to use the integration. So therefore, x of t is equal to integration from tau is equal to mass of t, tau is equal to plus of t, x of tau, delta of t minus tau into t tau. And y of t is equal to integration from tau is equal to mass of t, tau is equal to plus of t, x of tau, h of t minus tau into d tau. So this we can write simply x of t conjugation of h of t you can write. So y of t is nothing but x of t conjugation of h of t also you can write. So therefore we can say x of t is equal to integration from tau is equal to minus of t to plus of t, x of tau into delta of t minus tau into d tau. Y of t is equal to integration from tau is equal to minus of plus of t, x of tau into h of t minus tau into d tau, which you can write, which is x of t conjugation of x of t conjugation of h of t. So you can write like this. So finally, I can do the summary of this one. So let me write the summary. This is the discrete time domain and this is the continuous time domain. So let me write it. So x of n, I can write like this: sigma k is equal to minus infinity to cos infinity x of k into delta of n minus t. So whereas in the continuous time domain, we can write x of t is equal to v, sigma will become integration, or k will become tau. Tau is equal to minus infinity plus infinity x of tau into delta of p minus tau d tau. Here y of n will become sigma k is equal to minus infinity to plus infinity x of k into h of n minus k. Whereas here it will become y of t is equal to integration from tau is equal to minus infinity to plus infinity x of tau into h of p minus tau into d tau. So here we can write y of n is nothing but x of n convolution of h of n. We can write here y of t, I can write x of t convolution of h of t. This is what I am trying to tell you. So this is what I have basically said of this concept. So here with discrete time domain, x of n is equal to sigma k is equal to minus m to plus infinity s of k into delta of n minus k, and y of n is equal to sigma k is equal to minus m to plus infinity s of k into h of n minus k. So y of n is the x of n convolution of h of n. Here in the continuous time domain, x of t is equal to integration from tau is equal to minus m to plus infinity x of tau delta of t minus tau d tau, and y of t is equal to integration from tau is equal to minus m to plus infinity x of tau into h of t minus tau into d tau, and y of t is equal to x of the convolution of h of t. So these two things always you have to keep in your mind. Now let's go for the convolution properties. So now we are going to discuss the convolution properties in the discrete time domain. So for the discrete time domain, we are going to discuss the convolution properties. Then we will shift for the continuous time convolution properties also. We are going to discuss one after the another. So as you can see clearly here, f of n convolution of delta of n is always equal to f of n. So whenever you are doing a convolution with the impulse signal, same signal that you are going to get again. So whenever you are doing a convolution with respect to unit impulse signal, the same signal you are going to get back. So f of n convolution of delta of n is equal to f of n. So whenever you are doing a convolution with respect to delta of n, then you are going to get f of n itself. What's the meaning of this one? So what's the meaning of this one? Listen carefully. So here for a system, suppose if the input is delta of n, the output is nothing but h of n. Then h of n is nothing but suppose delta of n. So output is equal to input. So therefore, for f of n, what is the output? It is again f of n, because it is called as INP system. Whatever the input, same thing that we are going to get in the case of output also. So because we can say the impulse response of the system is nothing but delta of n itself. So that is the reason f of n convolution of delta of n is always equal to f of n. Means whenever we are doing a convolution with respect to unit impulse, the same signal that we are going to get back is f of n. So f of n convolution of delta of n is equal to f of n. Then f of n minus n naught convolution of delta of n, the same signal that we are going to get, just f of n minus n naught. So I have already told you, whatever the signal that you are going to do the conversion with respect to unit impulse signal, same signal that you are going to get back. So if you are going to do the convolution of any signal with respect to delta of n, the same signal is going to get back to f of n minus n naught. So f of n convolution of delta of n is called f of n, and f of n minus n naught convolution of delta of n is called f of n minus n naught. Similarly, f of n minus n naught convolution of delta of n minus n naught is equal to f of n minus of n naught plus n1. So in this formula, we have to remember f of n minus n naught convolution of delta of n minus n1 is equal to f of n minus of n naught plus n1. So this formula we have to always remember, because this is very much useful on doing the convolution. So f of n minus n naught convolution of delta of n minus n naught n1 is equal to f of n minus of n naught plus n1. So this is what I am trying to tell you. So f of n minus n naught convolution of delta of n minus n1 is equal to f of n minus of n naught plus n1. So take the minus common and do the addition of these two things. So always try to write in the standard format only. Try to write, then only we can make things very simple. So f of n minus n naught convolution of delta of n minus n1 is equal to f of n minus of n naught plus n1. Then I already told you, suppose for a system, listen carefully. Suppose for a system, yes, if the input is delta of n, then what is the output that you are going to get? Impulse response h of n. Suppose if you are going to give unit step signal as an input, then the response that you are going to call as a unit step response. So the delta of n is called as a, for a given system, if you give the input as delta of n, then you are going to get the output as h of n. For the same system, if you give the input as u of n, then the output then you are going to get this called as a s of n. The delta of n is called as a unit impulse signal, and h of n is called as a unit impulse response, and u of n is called as a unit step signal, and s of n is called as a unit, we can say unit step response. So now I want to find a relation between these two things. So if you know the relation between these two things, then getting the relation between these two things is also very simple. So I've already told you, which is see u of n. So u of n is nothing but u of n is equal to sigma k is equal to minus infinity then, which is delta of k, right? So the delta of right, because I've already told you, which is the unit step signal is the integration of the impulse. Unit step signal is the integration of the impulse signal. So u of n is equal to sigma k is equal to minus into n delta of k. So when n is less than 0, this value is always equal to 0. If n is greater or equal to 0, always this value you are going to get 1. So then we carry it in the same fashion. So for u of n, what is the response? Which is s of n. Then for delta of k, what is the response? For delta of n, the response is h of n. Delta of k, what is the response? H of k. So h of k. Right, same thing. It is sigma k is equal to minus infinity plus infinity. Sorry, to n only. So to n. So this is what I am trying to tell you. So s of n is equal to sigma k is equal to minus infinity n h of k. So as I already told you for this one, so this one you have to remember. For a system with the input is h of n, the output is h of n. For the same system, the input is u of n, the output is s of n. So already you know the relation between u of n and delta of n, which is u of n is equal to sigma k is equal to minus infinity k is equal to n with delta of k. So similarly, we can get the relation between these two things also. For u of n, what is the response? S of n. And for delta of n, the response is h of n. So for the delta of k, what is the response? H of k. I would then get the signal same as it is. Sigma k is equal to minus infinity k is equal to n. So s of n is equal to sigma k is equal to minus infinity to k is equal to n. H of k. Then what is reverse? I want to find the reverse thing. So basically, if you know h of n, then you can get the value of s of n in this formula. Suppose if you want the s of n, if you know s of n, how to get the h of n, which is h of n is equal to s of n minus s of n minus 1. So the impulse response is the first difference of the step response. So unit impulse response is the difference. It is a difference of the it's the first difference of the unit step response. So h of n is equal to s of n minus s of n minus 1. So this is the thing always you have to keep in your mind. So basically, so I wanted to then how you can write delta of n. So I want to write delta of n in terms of u of n. So delta of n is nothing but u of n minus u of n minus 1. You want to do that? So if you know delta of n is nothing but u of n minus u of n minus 1. So for when u of n is an input, what is the response h of n? So for u of n is a response, what is that? If u of n is a response, what is that? If u of n is an input, what is the response s of n? For u of n minus 1 is the input, then what is the response s of n minus 1? So this is what I'm trying to tell you. So these things always you have to keep in mind. So if you know the relation of the inputs, then you can get the relation of the outputs in a very simple manner we can get. So you can say u of n is equal to sigma k is equal to minus m to n delta of k. So from this we can say s of n is equal to sigma k is equal to minus m to n h of k. Similarly, delta of n is equal to u of n minus u of n minus 1. So if you know the relation, then we can get the h of n is equal to s of n minus s of n minus 1. So if you know the relation, we can get back the response. If you know the input signal response, if you know the input signal relations, then we can get the output signal response also you can get. So s of n is equal to sigma k is equal to minus m to n h of k, and h of n is equal to s of n minus s of n minus 1. Then the next formula is delta of n minus n1 convolution of delta of n minus n2 is equal to delta of n minus of n1 plus n2. Same formula. So this formula just now we have discussed, right? So this formula just now we have discussed, right? So therefore, with the help of this formula, we can get this one, which is delta of n minus n1 convolution of delta of n minus n2 is equal to delta of n minus of n1 plus n2. So these things always you have to keep in mind. So I can give a general formula. I can give. Let me write here. So let me write the general formula. F of n minus n1 convolution of delta of n minus n2. So is equal to general formula, which is f of n minus of n1 plus n2. So this is a general formula I can give. So f of n minus n1 convolution of delta of n minus n2 is equal to f of n minus of n1 plus n2. So this formula always you have to keep in your mind. So this is a general formula always you have to keep in your mind. So f of n minus n1 convolution of delta of n minus n2 is equal to f of n minus of n1 plus n2. So if you remember the general formula, everything is simple. So therefore, f of n minus n1 convolution of delta of n minus n2 is equal to f of n minus of n1 plus n2. So this is the important formula always you have to keep in mind. So now we have successfully covered the discrete time convolution properties. Now let's go for the continuous case, continuous time convolution properties we are going to discuss in a very detailed manner. So continuous time. So if you know discrete time properties, then with the help of that we can get back the continuous time properties also we can get. So if you know the discrete time convolution properties, then easily we can get the continuous time properties also we can easily get. So let me see one after the another. So f of t convolution of h of t is equal to h of t convolution of f of t, because in order to that convolution is going to satisfy the commutative property. So a into b is equal to b into a. Similarly, f of t convolution of h of t is equal to h of the convolution of f of t. So what is the meaning of that one? What's the meaning of this one is, here in this case, suppose if the input is f of t and if the impulse response is h of t, then you are going to get a certain output. Or reverse also, if the input is h of t and if the impulse response is f of t, then also you are going to get the same output. So this is what I am trying to tell you. Suppose for a given system, if the input is f of t and if the impulse response is h of t, then you are going to get certain output. If you take another system which is having the input as h of t and the impulse response is f of t, then also you are going to get the same output. So therefore, this is what I am trying to tell you. So f of the convolution of h of t is equal to h of the convolution of f of t. So that convolution is going to satisfy the commutative property. So now, f of t convolution of h1 of t plus h2 of t is equal to, this take the convolution inside. So f of t convolution of h1 of t plus f of t convolution of h2 of t. So let's take inside. So therefore we can say f of t convolution of h1 of t. So f of t convolution of h1 of t plus h2 of t is nothing but f of t convolution of h1 of t plus f of t convolution of h2 of t. So what is the meaning of this one? So what is the meaning of this one is very simple. So very simple. Suppose if you take a parallel system, one is having the impulse response H1 and you take the other system is having the impulse response H2. So if you are going to use the same input for both of this, then I am going to use a summer here. I am going to use summer. So I am going to use certain output Y, where the input is here. So here, what is the response here? Which is f of n convolution of h1 of n. Here, f of n convolution of h2 of n. So what is the output Y? Y is solution of these two outputs, which is f of, and it is in the terms of time analysis below. F of the convolution of h1 of t plus f of the convolution of h2 of t. Instead of that, I will go for a simple thing. Basically, I will add this impulse response. Then I will give the input f of t. Then I am going to get the output as well. So instead of going for this complex circuit, I will use simple circuit. This simple circuit has impulse response. The summation of these two impulse response, then you are going to get the same output. So therefore, here this is a parallel system. So this is a complex system, right? So instead of that, I will take a new system serving impulse response. The summation of the impulse response, then I am going to get the same output. So therefore, we can say here for the system, the output is f of the convolution of h1 of t. Here the output is f of the convolution of h2 of t. And what is the output here? Summation of these two outputs, which is f of the convolution of h1 of t plus f of the convolution of h2 of t. So instead of that, I will do basically here. So what I will do? So here I will take f of t as a common. So f of the convolution of h1 of t plus h2 of t I can write. So what is the meaning of this one? So there is a new system. For the system, the impulse response is summation of the impulse response, which is h1 of t plus h2 of t. Then I am going to get the input as f of t. Then I am going to get the output same as the previous output. So therefore, whenever you are going to make the systems in parallel, the simplified circuit will have the impulse response, the summation of the impulse response. So listen carefully. Whenever you are going to put the systems in parallel, so instead of that, I will take a simplified circuit. For the circuit, the impulse response is the summation of the all impulse response. That's it. So we are going to get the solution. So therefore, in the case of parallel system, the net impulse response is nothing but summation of the individual impulse response, as you can see clearly from this picture. So like this, always you have to analyze. Then, so like this, I am going to tell you, if for each and everything, I am going to explain in a very detailed manner, so that you can able to visualize what I am trying to tell you with those questions also. See, blindly don't remember the formulas, understand the concepts behind that. Then only, even though if you forget the formula, in the examinations, we can make things in a very simplified manner. Then, the next point is f of t convolution of h1 of t convolution of h2 of t is nothing but. So basically, instead of that, keeping bracket here, I can keep bracket here also. So therefore, f of t convolution of h1 of t convolution of h2 of t also I can get. So here f of t convolution of h1 of f of t convolution of h1 of t convolution of h2 of t is nothing but I can keep bracket here also f of t convolution of h1 of t whole convolution of h2 of t. So what is the meaning of this one? So what is the meaning of this one? It's very simple. Suppose let me take two systems. I am going now doing the cascade fashion. Here the input is f. Here the input response is h. So what is the output here? F convolution of h1. Suppose there for the system the input response is h2. Then what is the output here? Which is f convolution of h1 again whole convolution of h2, right? So this is the output. So instead of that, what I will do like this. Instead of that, I will take a simplified circuit. Then I can write like h1 convolution of h2. So this is simplified circuit as an impulse response, is a convolution of the initial impulse response. Then I will do the input f. Then what is the output I am going to get? F convolution of h1 convolution of h2, right? So therefore, this is what? So both are same. So you can see f of t convolution of h1 of t convolution of h2 of t. Again here you can see f of t convolution of h1 of t whole convolution of h2. So both the response are same. So therefore we can say whenever the systems are cascaded, series connected, then the net system, a simplified network, impulse response is the combination of the individual impulse response. So finally, I can listen carefully. Suppose if you are going to create the systems in cascade manner, and if you want the equivalent system, then this equivalent system impulse response is nothing but the convolution of the individual system's impulse response. Similarly, if you keep the systems in parallel fashion, and if you want a simplified circuit impulse response, then its impulse response is the summation of all the impulse response. So these one always have to keep in mind. So finally, I can say, suppose if you are going to connect the systems in cascade fashion, so if you are going to connect the systems in cascade fashion, then the simplified circuit will have the impulse response, which is the combination of all the individual system impulse response. Suppose if you are going to connect the systems in parallel fashion, then the simplified circuit will have the impulse response, which is a summation of all the individual impulse responses. So this is a point always you have to keep in your mind. Then the next thing is f of t convolution of delta of t is equal to f of t. And what I told you, if you take any signal and if you do a convolution with respect to delta impulse signal, the same thing you are going to get, this f of t only that you are going to get. So f of t convolution of the delta of t is equal to f of t. So I already told you, if you take any signal and if you do convolution with respect to delta of t, same signal that you are going to get, which is f of t only you are going to get. So this would always you have to keep in your mind. Then f of t minus t1 convolution of delta of t minus t2 is equal to f of t minus of t1 plus t2. So this one I have already told you. So f of t minus t1 convolution of delta of t minus t2 is equal to f of t minus of t1 plus t2. So this formula just now we have discussed, right? So f of t minus t1 convolution of delta of t minus t2 is equal to f of t minus of t1 plus t2. So this formula just now we have discussed. So again, f of t minus t1 convolution of delta of t, I already told you, you take irrespective of whichever signal you take, and if you do the conversion to delta of t, same signal that we are going to get is f of t minus t1. So or you can use this formula also. If you use this formula and t2 is equal to 0, the substance simplify, same thing we are going to get f of t minus t1. So same thing we are going to get. So these things always you have to keep in your mind. Then listen carefully. So listen carefully what I am trying to tell you. So these points are very, very important. Suppose if you take y of t, so y of t is the, suppose f of t convolution of h of t, I am going to get. Suppose if you want to find dy of t by dt, then you can write like this: f of t convolution of derivative of h of t by dt, or you can write like this: derivative of f of t convolution of h of t. So this is the important point always you have to keep in your mind. Suppose for a given system, suppose if the input is f of t and the impulse response is h of t, then output you are going to get y of t. Suppose if you want basically, so listen carefully. Suppose there is a system like this. For the system, the input response is h of t, and the signal input is f of t, then the output you got y of t. Suppose if you take another system, for the system I want the impulse response as y dash of t, previous. The response as y dash of t, then what is the input I need and what is the impulse response I need here. So then the input can be either f dash or f dash and the impulse response is h, or vice versa, which is the input can be f and the impulse response is h dash. So anything can be happen. So listen carefully. Here what I am trying to do is very simple. Suppose for a given system, if the input is h and if the impulse response is if the input is f and if the impulse response is h, then the output that we are going to get is y. So here, suppose if I take another system, for this output I need the derivative of the previous output, which is y dash I want to get. Then what is the input and what is the impulse response for this new system I want, which is the input can be either f dash and the impulse response is h, or the input can be f, then impulse response is h dash. So this is what I am trying to tell you. So therefore we can say y of t is equal to f of t convolution of h of t, y of t is equal to f of t convolution of h of t, then dy by dt is nothing but f of t convolution of dh of t by dt, or df of t by dt convolution of h of t. So this is what I am trying to tell you. Then the next one, so like this always you have to analyze. So what I am trying to tell you, you need to analyze like this, then only the things are going to become very much simple. So just don't remember the formulas. Try to visualize what I am trying to tell you. Then only you can basically solve the questions which are going to come in the examination. So like this is the attitude. You need to have a very good attitude in the examination, because see, you may fail low. During preparation, every person is going to fail low. It is a very common thing. But the only thing is, no matter whatever the things are going to happen, do it slowly, one after the other. Things are going to become normal. So every student is going to face same type of pressure and same type of pressure things, but you have to move on. Then the next thing is, so listen carefully this formula. Then listen carefully. Suppose if the f of t convolution of h of t is nothing but y of t, then f of a t, this formula is very important. F of a t convolution of h of a t, this formula is very important, which is equal to 1 by mod a into y of a t. So this is a very important formula. A can be either positive or A can be negative. So this is a very important formula. Definitely will get confusion from this formula. So that is the reason I am recommending you to remember this formula for so many number of times. So therefore we can say that. So we can say that simply. So therefore we can say f of t convolution of h of t is equal to y of t. Then f of a t convolution of h of a t is equal to 1 by mod a y of a t. Here A can be either positive, A can be either negative. So here what I have did, I have replaced t by a t. Here also t by 80, here also t by 80, but extra factor 1 by mod you have to keep here. So this derivation I have already told you in my signal and system conceptual classes. But this is a recent class, this is a former recent class, so you have to remember the formulas. So f of t convolution of h of t is equal to y of t, then f of a t convolution of y of a t, h of a t is equal to 1 by mod a into y of a t. So this formula always you have to keep in mind, and A can be the positive or A can be even negative also. So f of t convolution of h of t is equal to y of t, then f of a t convolution of h of a t is equal to 1 by mod a into y of a t. So this is what I am trying to tell you. Here A can be the positive or A can be the negative also. So this is a important thing always you have to keep in your mind. So finally I can say f of t convolution of h of t is equal to y of t, then f of a t convolution of h of a t is equal to 1 by mod a into y of a t. Here A can be the positive and A can be the negative. Then the next formula is, see, there is also one more formula. Then suppose f of t convolution of h of t is equal to y of t, then f of t minus a convolution of h of t minus b, which is equal to y of t minus of a plus b. It's the same formula that we have discussed now. So these two formulas always you have to keep in your mind. So therefore we can say here f of t convolution of h of t is equal to y of t, then f of t minus a convolution of h of t minus b is equal to, we can say y of t minus of a plus b. So this formula always you have to remember. So f of t convolution of h of t is equal to y of t, then f of t minus a convolution of h of t minus b is equal to y of t minus of a plus b. So this formula always you have to keep in your mind. So therefore finally these are the very important formulas always you have to keep in your mind. So f of t convolution of h of t is equal to y of t, then f of a t convolution of h of a t is equal to 1 by mod a into y of a t, where A can be positive, A can be negative, and f of t minus a convolution of h of t minus b is equal to y of t minus of a plus b. So these formulas always you have to keep in your mind. Now we'll discuss some more points, which is, I've already told you, which is y dash of t is equal to f of t convolution of s dash of t or f dash of t convolution of h of t. I've already told you this point so many number of times. So y dash of t is nothing but f of t convolution of h dash of t or f dash of t convolution of h of t. I've already told you. Suppose now this is a general expression regarding the derivative. So nth derivative of y of t is equal to rth derivative of f of t convolution of nth derivative of h of t. So always n is equal to r plus m. N is equal to r plus m. So nth derivative of y of t is always equal to rth derivative of f of t convolution of nth derivative of h of t. So always n is equal to r plus m. N is equal to r plus m. So if you see clearly, suppose if I substitute n is equal to 1, then this r value can be either, if r value is equal to 0 means m value is equal to 1. If r value is equal to 1 means m value should be equal to 0, then only the summation will be equal to 1. Suppose if r is equal to 0 and m is equal to 1 means we are going to get this one. See, r is equal to 0 means there is no derivative itself. There is no derivative means take the signal f of t as it is. Here, now, if r is equal to 1 and m is equal to 0, m is equal to 0 means there is no derivative of h of t means take as it is. So h of t, so therefore f dash of the convolution of h of t. So if you remember this one, we can get for any derivative, we can easily get. We can go for the any derivative, we can get. So now, let me go for the double derivative. So here, double derivative. So what is the meaning of n? Here n is equal to 2. So n is equal to 2. So n is equal to 2. How many ways we can go for r and m? So here r is equal to 0 and m is equal to 2. This is one case. Or r is equal to 1 and m is equal to 1. So this is another case. And r is equal to 2 and m is equal to 0. So this is the another case. Is any other case possible? 0 to 1, 1, no 0. Any other case possible? No, only these three cases are possible. So therefore, apply this one. So case 1 here, r is equal to 0 means f of t same as it is. N is equal to means second derivative. So h double dash of t is equal to, again, here r is equal to 1 and m is equal to 1. R is equal to 1 means first derivative of dash of t. M is equal to 1 means first derivative of dash of t. Convolution. Third case, r is equal to 2 means second derivative. So f double dash of t convolution. Here n is equal to 0. Means there is no derivative. Means take as it is h of t. So this is way always you have to keep in your mind. So always remember, and the derivative of y of t is equal to r the derivative of f of t convolution of and the derivative of h of t, and n is always equal to r plus n. N is always equal to r plus n. 0 means definitely there is no derivative. Means take the signal as it is. Suppose if n is equal to 3, then what is going to happen? So let me give a different ideas. So I am going to give you a different ideas. So let me go for the, suppose if n is equal to 3, then what is going to happen? Let me write here. So let me write here. Suppose if n is equal to 3, then what we have to do? What we have to do? Let me represent here. If n is equal to 3 means r can be 2, m can be 1. Or here r can be 1 and m can be 2. Then any other possible? No, only these two are possible. As you can see clearly, 2 or 1 or 2. Any other possible? Or you can S 0 and 3 also possible, right? 0 and 3. Or you can say r is equal to 3 and m is equal to 0. This is also possible. Any other possible? No. Only these are possible. So these are the different cases. And n is equal to 3. So like this you have to remember. So n is equal to m plus r. So if you remember this concept, then you can go for it. Any other thing you can easily go. So always remember, nth derivative of y of t is equal to r derivative of f of t and nth derivative of h of t. So these things always you have to keep in mind, and n is always equal to r plus n. N is equal to r plus n. So 0 means there is no derivative. Means take this only as it is. So isn't it very clear? 0 derivative means d by dt. 0 derivative. Any power of 0 is nothing but 1. So 1. That's it. I'm trying to tell you. So therefore we can say simply that nth derivative of phi of t is equal to r the derivative of f of t, convolution of nth derivative of h of t, and n value is always equal to r plus n. So n value is equal to r plus n. So this formula always you have to keep in your mind. So here I have given for second derivative, here no derivative, yes two derivatives, second derivative, here one derivative, one derivative, here second derivative and 0. If you add all these derivatives, you should give always equal to 0 plus 2 is equal to 1 plus 1 is equal to 2, 2 plus 0 is equal to 2. So this is what I am trying to tell you. So this generalized formula always you have to keep in mind. So n the derivative of y of t is equal to r the derivative of f of t, convolution of nth derivative of h of t, and n is always equal to r plus n. N is always equal to r plus n. So this point always you have to keep in your mind. So n value is equal to r plus n. This point always you have to keep in your mind. So no derivative is take the signal as it is. Now the next thing is, I have already told you this point so many number of times. So for a given system, if the input is delta of t, then what is the impulse response, which is h of t? Suppose if the input is u of t, then what is the response, step response s of t? So what the relation, what I told you, if you know the input relations, then you can also get the output relations. So delta of t is nothing but delta of t is the derivative of the step signal. And same thing for the response also same thing, which is delta of t, what is the response, h of t. And for step signal, what is the response, step response s of t. So you can see h of t is equal to d by dt of s of t, as you can see clearly here. Then if you know s of t, you can get h of t from this relation. Vice versa. The remaining thing is u of t is nothing but the step signal is the integration of the input signal. So u is equal to minus infinity t h of tau, delta of tau d. So for u of t, what is the response? The response is s of t. So s of t is equal to integration from tau is equal to minus infinity to t. For delta of t, what is the response, h of t? For delta of tau, the response is h of tau. So h of tau dt. That's it. So you can see clearly here, h of t is equal to d by dt of s of t. and S of t is equal to integration from tau is equal to minus t, tau is equal to t, h of tau d2. So this is what I'm trying to tell you. So these things always you have to keep in mind. So if you know step response, then by using this we can get the impulse response. So if you know impulse response, then we can get the step response by this relation. So if you know the input signal relations, then we can get the output signal relations also. So this is what I'm trying to tell you. So the impulse response is that, so we can say that the impulse signal is the derivative of the step signal, and the step signal is the integration of the impulse response. So if you remember this thing, we can get the output response also, you can get very easily. Then the next thing is, so this is a very, very important concept. Let me grab this basic thing so that I can explain what I'm trying to tell you from this concept. So here what they have given, y of t is equal to x of t convolution of h of t. So x of t convolution of h of t. So x of t is the input and h of t is the unit impulse response. And h of t is nothing but, you can see by this relation, d by dt of h of t. So h of t is the unit impulse response is the derivative of the step response. So in place of h of t, I have substituted d by dt of h of t. So now I am going to take this derivative outside. Just d by dt of x of t convolution of s of t also true. Why it is like this? Let me represent here. So here for this part, you see x of t convolution of d by dt of s of t. I am going to write the relation. How I am going to write the relation? Listen carefully. So x of t convolution of h of t is integration from tau is equal to minus infinity to tau is equal to plus infinity. X of tau into h of t minus tau d2. So this is for this one. So for this one I have written. So this is for this one I have written. But here what they have done, h of t is a d by dt of s of t. So h of t is a d by dt of s of t. So now I will try to write here h of t minus tau. So h of t is d by dt of s of t. Then h of t minus tau is nothing but d by dt of s of t minus tau. So same thing here. Therefore, integration from tau is equal to minus infinity to plus infinity, x of tau into inverse of h of t is nothing but d by dt of s of t, and h of t minus tau is nothing but d by dt of s of t minus tau. So therefore, d by dt of s of t minus tau dt, right? So basically, if you see clearly, I am doing with respect to t, derivative I am doing with respect to t, but here, so I am doing with respect to t means tau is I am not dealing with respect to tau, only I am dealing with respect to t, time unit t. So I can take it outside because there is only one signal t, portion of t, but the signal is with respect to tau. So I know that I don't need this value because it's a constant because I am doing with respect to t. So I can take it outside because this is constant. It's a constant, it can go inside, right? So these things always go inside. Then I can take this one outside. So that is the reason. So what it will become? It will become d by dt of integration from plus tau is equal to minus infinity to plus infinity x of tau s of t minus tau into v2. So this is nothing but, this signal is nothing but finally I am going to get d by dt of, which is x of t convolution of s of t. So this is what I am trying to tell you. So this is clearly, as I already told you, that h of t is nothing but d by dt of s of t. So basically, here, if you expand, basically we are dealing with respect to t. So only one function is a function of t, and the other thing is a function with respect to tau. So it will become constant because I am dealing with respect to t. So constant means it can go inside and it will come outside. So this will become now x of t convolution of s, x of t convolution of s of t, x of t convolution of s of t. So therefore I can write d by dt of x of t convolution of s of t. So this is what I am trying to tell you. So finally I can say y of t is equal to x of t convolution of h of t, whereas h of t is the d by dt of s of t, as only s of t is a function of t, and if we expand this one, and x of t is a function of tau, whereas s of t is a function of s of t minus tau. So only s of signal is a function of t, whereas remaining t is a function of tau. So I can take it outside. So therefore it will become d by dt of x of t convolution of s of t. As you can see clearly, I have proved this one also. So therefore we can write like this. So therefore d by dt of x of t convolution of s of t also we can write. So these are the different ways of writing. So these things always you have to keep in mind. So now we are going to discuss some more important things, which is we are going to define the system properties in terms of impulse response h of t. So basically So previously what we have learned for a given system, we have learned about the different types of properties we have discussed in a very detailed manner. But now we are going to discuss those properties in terms of impulse response. So in terms of impulse response, so previously we have learned about the system properties, right? Now we are going to discuss those system properties in terms of impulse response. So if you study the impulse response, then we can tell what type of system it is, what are the properties which are going to hold in that system, we can tell. So just by studying the impulse response clear cut, then we can tell the system what are the properties which are contained in that system, we can easily tell. So listen carefully. Suppose if you study the impulse response correctly, we can tell what is a system properties are present in that system, we can easily tell. So therefore, the system properties in terms of h of t means, suppose for a given system, if we give delta of t, then we got h of t. So if we study that h of t very clearly, then we can say what are the properties that are going to present in that system, we can easily know. So listen carefully. Causal LTI system. I already told you what is the meaning of causal LTI system. Causal LTI system. What is the meaning of causal LTI system? I've already told you so many number of times, which is so what's the meaning of causal LTI system? I've already told you, which is a system is said to be causal only when the present output is independent of the future values of the input. Then only we can say it is a causal LTI system. Then how we can say with the help of impulse response, which is if h of n is equal to 0 for n less than 0 or h of t is equal to 0 for t less than 0, then we can say the system is said to be the causal system, causal LTI system, because listen carefully, if h of n is equal to 0 for t less than 0 or h of t is equal to 0 for t less than 0, means if the impulse response h of n is equal to 0 for n less than 0 or h of t is equal to 0 for t less than 0, then only we can say the present output is independent of the future values of the input. So therefore we can say if h of n is equal to 0 for n less than 0 or h of t is equal to 0 for t less than 0, then we can say clearly that the present output is independent of the future values of the input. So we can say the system is said to be LTI, it is said to be causal LTI system. The next thing is static LTI system. So how we can say this the system is said to be a static LTI system? How we can say? I've already told you what is the meaning of static LTI system. Static means if the present output is depending only on the present values of the input, then we can say it is said to be static system. Dynamic system is the present value of the input is depending upon the past values of the input. So if the present value of the output is depending on the past values of the input, then we can say it is a dynamic system. It is having memory. How we can say like this? So see from the impulse response, which is if h of n is equal to a delta of n or h of t is equal to a delta of t, then only we can say the system is said to be static LTI system. Means the output is depending only on the present value of the input. So present output is depending only on the present value of the input. Then only we can say like that. So therefore we can say if h of n is equal to a delta of n or h of t is equal to a delta of t, then only we can say that the system is said to be a static system because the present output is depending only on the present values of the input. Then only we can say it's a static system. Suppose if the impulse response is not in this case, then definitely it will become a dynamic system. So then carefully, if the impulse response is not in this like this case, definitely it will become a dynamic system. So now let's go for this stable LTI system. So how we can say the LTI system is stable or not? How we can say like that? How we can say whether a given LTI system is stable or not? How we can tell? Which is basically, see, I've already told you what is the meaning of stable system. Stable system is for every bounded input, if you are going to get a bound output, then only we can say the system is said to be stable system. Even for any one bounded input, if the output is unbounded, then we can say the system is said to be unstable system. Listen carefully. For every bounded input, if you get the bounded output, then only we can say the system is said to be a stable system. Even at least for one case, if for a bounded input, if you are going to get a bounded output, then we can say the system is said to be unstable. So, how we are going to define the stability in the terms of impulse response, which is when sigma n is equal to minus n to plus infinity mod of h of n if it is less than infinity, integration from t is equal to minus n to plus infinity h of t mod of h of t dt if it is less than infinity, then we can say it is said to be stability system. Means first you have to find what is the modulus of the h of t or h of n and try to find the area under that signal, and if you are going to get a finite area, then we can say it is a stable system. If you are going to get an infinite area, then it is an unstable system. Listen carefully. try to figure out the magnitude value of the impulse response and try first figure out the magnitude value of the impulse response and then try to find the area under that impulse response. And if you are going to get a finite area, then we can say it is a stable system. If it is if you are going to get infinite area, then it is a unstable system. This is what we can say. So therefore, the area under the impulse response means if the under the area under the magnitude of the impulse response if it is finite, then we can say the stable system. But if it is close to infinity, means it is said to be unstable system. So these things always you have to keep in your mind. Then the invertibility LTI system. How we can say a given LTI system is a invertible or not? Invertible or not? How we can say? Which is basically we can say that. So I already told you for the given system is the impulse response is h of t. For the inverse system, the impulse response is ha of t. If the convolution of these two things, if you are going to get delta of t, then only we can say the system is invertible. Otherwise, it is a non-invertible system. So h of n convolution of h of n, if it is equal to delta of n, then also we can say the system is said to be invertible system. So these things always you have to keep in mind. So let me represent here. Suppose this is a system n. For this, the impulse response is delta of if this impulse response is present carefully, this is a system. This impulse response is h of n. If the input is x of n, so what is the output that we are going to get, which is equal to x of n convolution of h of n, right? So sorry, listen carefully. Suppose this is another system. This is having the impulse response hi of n. So now, what I want to do, what I told you, whenever two systems, if you are going to cut in cascade, the simplified circuit will have an impulse response which is h of n convolution of hi of n. Suppose if the input is x of n, and if you want the output to be same as the here, your output is also equal to x of n, then the output is I of n. If you want the same output x of n, then definitely this x of n convolution of hi of n should be equal to delta of n. Then only this is possible. So this is what I am trying to tell you. So therefore, you can see the convolution of the h of n. So the convolution of the h of t and convolution of h of t, it should be equal to delta of t, or the convolution of h of n convolution of h of n should be equal to delta of n. Then only we can say it is said to be invertible LTI system. Means we can say simply that what I am trying to tell you, the system impulse response and the inverse system impulse response, if you do a combination of these two things, then we should get an impulse signal. Then only we can, the system is said to be LTI system, isn't it? Then only we can say it is an invertibility LTI system. So for the system impulse response and the inverse system impulse response, to the combination of these two things, and if you get the delta of n as the impulse response, then delta of n as the impulse signal, then we can say the system is said to be invertibility LTI system. So finally, I can do the conclusion. So just by I have told you the properties of a system. So basically I have told you all the system properties I have already told you. But now just by for a given system, for a given LTI system, if you are going to give the impulse input and you are going to get the impulse response. So just by studying the impulse response, you can say what are the properties which are going to present in the system. We can tell how it is. For causal LTI system, the h of n is equal to 0 for n less than 0, or h of t is equal to 0 for t less than 0. Then we can say the system is said to be causal LTI system is the present output is independent of the future values of the input. And the static LTI system means the impulse response should be h of n is equal to a delta of n, or h of t is equal to a delta of t. Then we can say the system is said to be static LTI system is the present output is depending only on the present values of the input. Then we can, it is said to be static LTI system. If it is not satisfying this condition, means it will be dynamic system. If it is not satisfying this condition, means it will be non-causal system. Similarly, stability system is what we told. For every bound input, if you are going to get a bound output, then we are going to, for every bound input, if you are going to get a bound output, then we can say it is a stable system. Even for at least one bound input, if you are going to get unbound output, then we can say it is a unstable LTI system. So here, first to find we can say first to find the modulus of the impulse signal and try to find the area under the modulus of the impulse signal. You can say so basically try to find the modulus of the impulse response. And now find the area under that. If the area is equal to finite, we can say with a stable system, if it is not satisfying this condition, means it will become unstable system. So sigma n is equal to minus infinity plus infinity, mod of h of n should be less than infinity, or integration from t is equal to minus infinity plus infinity, mod of h of t dt should be less than infinity. If this condition is satisfied, then only we can say it is a stable LTI system, otherwise non unstable LTI system. Similarly, how to say whether a given LTI system is a invertible LTI system or not? So the given LTI system, given LTI system impulse response and the inverse system impulse response. So do the combination of these two things, and if you get the impulse response, then we can say it is a invertible LTI system. Otherwise, it is a non-invertible LTI system. So h of t combination of h of t is equal to delta of n, or h of n combination of h of n is equal to delta of n. Then we can say it is a invertible LTI system. Otherwise, it is a non-invertible LTI system. So these things always you have to keep in mind. So finally, I can repeat the concept, which is, so basically I have told you the system properties, but now I want to just for a given system by giving the impulse input, I'm going to give the impulse response. So just by studying the impulse response, I can tell what are the properties which are going to present in the system, I can say. So for a given LTI system, I'm going to analyze. So for a causal LTI system means what is the thing here. So a given LTI system, when it will become causal, means basically if the impulse response is equal to 0 for m less than 0, or for h of t is equal to 0 for t less than 0, means the impulse response is 0 for t less than 0, then we can say the system is said to be causal. If this condition is not satisfied, means it will become non-causal system. Means what's the meaning of causal? The present value of the output is independent of the future values of the input, then we can say it is a causal system. Then comes the static LTI system. So how can we say the system, the given LTI system is static or not? When the impulse response h of n is equal to a delta of n, or h of t is equal to a delta of t, means when the impulse response is the scalar multiple of the impulse signal, then only we can say it is a static LTI system. Static LTI system is the present output is depending only on the present value of the input. If this condition is not satisfied, means it will become dynamic system, means the present output is also depending on the past values of the input. Then comes the stable LTI system. So how we can say a given LTI system is stable or not, just by analyzing the impulse response. So first we go from the modulus of the impulse response and try to find the area under that impulse response. Try to find the area under the magnitude of the impulse response. If the area is finite, we can say it is a stable system. If it is equal to infinity, means it is an unstable system. So sigma n is equal to minus infinity plus infinity mod of h of n less than infinity, or integration from t is equal to minus infinity plus infinity mod of h of t dt less than infinity. Then we can say it is a stable system. If this condition is not satisfied, means it is an unstable system. So what is the meaning of stable system? For every bound input, if you are going to get bound output, or for every bound input, if you are going to get bound output, then only we can say it is a stable system. Even for one case, for bound input, if you are going to get unbound output, then we can say it is an unstable system. Then comes the invertibility LTI system. How to say whether a given LTI system is invertible or not? So for a given system, try to find the impulse response, and for the inverse system, try to find the impulse response, and do the combination of these two impulse response. And if you are going to get the resultant as the impulse signal, then we can say it is a invertible LTI system. So h of n convolution of h of n is equal to delta of n, or h of the convolution of h of t is equal to delta of t, then only we can say it is an invertible system. If this condition is not satisfied, means it will become non-invertible system. So what's the meaning of invertibility? For every unique input, we are going to get a unique output, or we can say vice versa also. For every unique output, we are going to get the unique input. Then only we can say it is said to be invertible system. So let me give a small clarity regarding this one. Suppose I have already told you there is some system y is equal to x square, y is equal to x square. So for input x is equal to minus 1 as well as the plus 1, the output is equal to 1. So this system is definitely, for so many inputs, we are going to get the same input, same output. So we can say definitely it is a non-invertible system. So let me explain here. So this is the system that y is equal to x square. So I want to find an invertible system. So this is an invertible system I want to figure out. Suppose here the input is minus 1, then the output I got 1. Then definitely I should take the output as minus 1. But what will happen for y is equal to 1? There are so many inputs which are having y is equal to 1, minus 1 and plus 1. So the output can be either minus 1 or the output can be either 1. So definitely we can say it is a non-invertible system, because for every unique input there is a unique output. Similarly, for every unique output, there should be unique input. So here, for the system, for -1 input, we got the output as 1. Now, but now, for this, if the system is inverse system, then here the output can be either -1 or +1. But we got only -1. So therefore, we can say this is a non-invertible system. For every unique input, you should get a unique output, or for every unique output, you should get a unique input. But here, for this unique output, we have so many unique inputs. So many inputs are there. So definitely this is a non-invertible system. So therefore, for example, for every unique input, if you are going to get a unique output, or for every unique output, we are going to get a unique input, then only we can say the system is said to be invertible system. Or we can say for non-zero inputs, listen carefully, for non-zero inputs, if you are going to get a zero output, then default it is a non-invertible system. For non-zero inputs, if you are going to get a zero input, for non-zero inputs, yes, for so many non-zero inputs, if you are going to get a zero output, definitely we can say it is a non-invertible system. So listen carefully, for non-zero input, if you are going to get a zero output, by default we can say it is a non-invertible system. So these things always you have to keep in your mind. Now we will discuss one more important concept, which is the signals. So we are going to discuss the different type of signals that are going to use in the signal system course. This is the first signal. We can say is a rectangular pulse. It's a rectangular pulse. Its magnitude is equal to 1 and is present only from -t/2 to +t/2, and the remaining part is equal to 0. So this is called a rectangular pulse. So you can say this is the signal of a rectangular pulse. Its magnitude is equal to 1 from -t/2 to t/2, and in the remaining time its value is equal to 0. So therefore we can express mathematically, which is f of t is equal to 1 for t lies from -t/2 to +t/2, and its value is equal to 0 in the other region. Otherwise, we can say otherwise. So we can say the rectangular pulse means simply we can say its magnitude is equal to 1 from -t/2 to t/2, and in the remaining period, in the remaining time it is equal to 0. So mathematically we can express f of t is equal to 1 for t lies from -t/2 to +t/2, and is equal to 0 otherwise, as you can see clearly from this picture. Now let's go for the another pulse, which is another signal, which is a triangular pulse. So this is the triangular pulse, as you can see clearly here. So this is called as a triangular pulse. So here at t is equal to 0, its value is equal to 1. So if you go from t lies from 0 to capital T, you can see the magnitude is going to get decreases, and finally at t is equal to its value is equal to 0. Again, afterwards its value is equal to 0. Similarly here also, from 0 to -t, as you go from 0 to -t, the function is going to get decrease, and finally it will become 0, and then afterwards it is equal to 0. So this is called a triangular pulse. So at t is equal to 0, its value is equal to 1. So mathematically, how we are going to represent this, f of t is equal to 1 minus t/t, at t lies from 0 to t. So you can see, suppose if you substitute small t is equal to capital T, then we are going to get its value is equal to 0. And if substitute t is equal to 0, then we are going to get its value is equal to 1. Similarly, for this region of the expression, which is for -t to 0, the expression of the function, which is f of t is equal to 1 plus t/t. If substitute t is equal to 0, then we are going to get its value is equal to 1. And if substitute t is equal to -t, then we are going to get its value is equal to 0. So this is the two things always you have to keep in mind. Suppose in case if you forgot the expression, how you can get easily, we can get this one. So here we do, this point is nothing but t comma 0. So this is t comma 0, and this is 0 comma 1. So you know the formula, y minus y1 is equal to m into x minus x1. So you know the slope, y minus y1 by x minus x1. Then y is nothing but f of t, right? So y is f of t. And what is x of t? That's it. The substitute is very simple. We are going to get the expression. Similarly, if you want the expression of the function from -t to 0, similar here also same thing. Here the point is 0 comma 1. Here the point is -t comma 0. Same thing. Y minus y1 is equal to m x minus x1. So m is y minus y1 by x minus x1. So y is nothing but f of t and m is nothing but t. And in each and everything, we substitute and simplify. We are going to get the expression. So for this one, we are going to get the expression. And in this one also, we are going to get the expression. So therefore, f of t is equal to 1 minus t/t for t lies from 0 to t. And its value is equal to 1 plus t/t for t lies from -t to 0. So this is what I am trying to tell you. So this is basically a triangular pulse. Now the next signal is the increasing exponential signal. So this is the increasing exponential signal. So this is the increasing exponential signal. So f of t is equal to e to the power of at. So f of t is equal to e to the power of at. This is called as a increasing exponential signal. See, a is a positive value. A is a positive value. Then only it will become increasing exponential value. So if you substitute t is equal to 0, then its value is equal to 1 here. If you substitute t is equal to 1, then its function is going to get increases. If you substitute t is equal to negative, then the function is going to get decreases. So you can see a graph like this. So if you go from here to here, from left side to right side, you can see the function is increasing. That is the reason it is called as increasing exponential signal. The next signal, f of t, which is the decreasing exponential signal. So decreasing exponential signal, the function resolution f of t is equal to the power of minus 80, that is positive. So if the substitute t is equal to 0, then we are going to its value is equal to 1. See, as t is increasing, as t is positive, so this overall function is going to get decreases. So it will decrease. If t is negative, this function is going to get increases like this one. So if we go from left side to right side, this function is going to get decreases. Whereas here, if you go from left side to right side, the function is increasing. So therefore, this is called as the increasing exponential signal, and this is called as the decreasing exponential signal. So these things allows you to keep in your mind. So f of t is equal to e to the power of 80, where a is equal to positive, it is an increasing exponential signal. And f of t is equal to e to the power of minus 80, where a is equal to positive, so it is a decreasing exponential signal. So these things always you have to keep in your mind. So now the next signal that we are going to discuss. So what is the next signal that we are going to discuss? It is very simple. So this is f of theta is equal to sin t. So sin t means, this is a graph that you are going to get. So this is a graph that you are going to get as a sine function graph. It is a periodic signal. So you can see the sine function with respect to theta. We are going to draw the maximum value is plus 1 and the minimum value is minus 1. So this is a graph we are going to get for the sine function. So these things I want to further explain. So this is a sine function. So this is a sine function graph. The maximum value is plus 1 and the minimum value is minus 1. It is going to lie only between this range. So for at a 0, at a pi, at 2 pi, at 3 pi, at 4 pi, all these things, or you can say at n pi, or we can say n pi, any of the integers. At these things, the function is always equal to 0. I have already told you, at the n pi, n is equal to integers. At these values of theta, the function is always equal to 0. It is always equal to 0. So these things always you have to keep in mind for a sine function. Now let's go for the cosine signal. Cosine signal means like this waveform, that like this waveform, we are going to get. It's a cosine function. So this is a cosine function. So you can see f of t is equal to cos theta. So this is a cosine function. Here the maximum value is plus 1 and the minimum value is minus 1. So this is going to lie within the range of plus 1 to minus 1. So this is a cosine signal. So if you see clearly here, you can say that its value is equal to, so basically this cos theta. So cos theta is nothing but, so you can see its value is equal to, you can see should basically we can say that at a 0 and at these values, its value is at a 0, at a 2 pi, at 3 pi, at 4 pi, like that. What is the value we are going to get? Its value is plus 1. At a pi, at a 3 pi, we are going to get minus 1. So therefore, we can say that definitely we can say its value is equal to minus 1 all the power of 1 n. At the n pi. So you can see the function cos theta is equal to minus 1 all the power of n for n pi. Suppose if substitute is equal to 1, then we are going to get at theta is equal to n pi. So at theta is equal to n pi. So here at theta is equal to n pi. So cos theta is equal to minus 1 all the power of n. At theta is equal to n pi. Suppose n is equal to plus 1, then we are going to get cos pi is equal to minus 1. As you can see clearly, cos pi is equal to minus 1. Suppose if substitute is equal to n is equal to, then we are going to get cos 2 pi is equal to minus 1 also is equal to 1. So you can see at 2 pi its value is equal to at 2 pi its value is equal to 1. So therefore we can say cos theta is equal to minus 1 all the power of n, where theta is equal to n pi. Theta is equal to n pi. So the cos function, the cos theta is equal to minus 1 all the power of n, and theta is equal to n pi, where n is the integers. So it can be positive, it can be negative. So we can say cos theta is equal to minus 1 all the power of n, and theta is equal to n pi. So n is basically integers. It can be plus 7 minus 2, or n can be also 0. If substitute n is equal to 0, then what is going to happen? Minus 1 all the power of 0 is nothing but 1. So cos 0 is nothing but simply 1. So we can say clearly at these things. So this is the graph of the cosine signal. Now let's go for the another signal. F of t is equal to u of t. So f of t is equal to u of t. So this is called the unit step signal. At t less than 0, its value is equal to 0. And at t greater than equal to 0, its value is equal to 1. So you can see clearly, at t less than 0, its value is equal to 0. And at t greater than equal to 0, its value is equal to 1. So f of t is equal to 1 for t greater than equal to 0. And its value is equal to 0 for t less than 0. So this is called as the unit step signal. So therefore we can say f of t is equal to u of t. So f of t is equal to u of t is a unit step signal. So for t less than 0, its value is equal to 0. And for t greater than equal to 0, its value is equal to 1. So mathematically I can write f of t is equal to 1 for t greater than equal to 0. And it is equal to 0 for t less than 0. So this is a pictorial way of arranging the signal, step signal, unit step signal. Then the impulse signal. What is the impulse signal? F of t is equal to delta of t. Here, like this pulse we are going to represent like arrow mark in the upward direction. And this area of the pulse is equal to 1. There is no magnitude. Suppose if you want the magnitude value it will be infinity. But because the width is very less, the height will be very high, then only the area is equal to 1. So because as the width is very less, then the height should be very high, then only we can say the area is equal to 1. So therefore the area under the impulse function is always equal to 1. So mathematically how we are going to represent f of t is equal to 0 at t not equal to 0 and is not equal to 0 at t is equal to 0. So not equal to 0 means definitely it will have a very infinite value, we can say the magnitude value. But always we are going to represent in the integral form, which is integration of the impulse signal from minus f to plus f t f of t dt. This is called as the integral graph which value is equal to 1. So this way we are going to represent the impulse signal where f of t is equal to delta of t in this case. So therefore we can say for an impulse signal f of t is equal to 0 and t not equal to 0 and its value is not equal to 0, t is equal to 0. Means at t is equal to 0, it's not this basically infinity, but always we are going to represent in the format of the area. So therefore integration from t is equal to minus f to plus infinity delta of t dt is equal to its area and the impulse function is always equal to 1. So these are the things always you have to keep in your mind. Now let's go for the another signal. So what is the next signal that we are going to discuss, which is f of t is equal to sin t by t. So sin t by t, I've already told you in shortcut how we are going to represent sa t, sa of t. I've already told you how we are going to represent this sa of t. Sa of t, I've already told you this point. Sa of t is nothing but sa of t is nothing but I've already told you sin t by t. And the sinc of t, I've already told you sinc of t is nothing but sin pi t by pi t. So these things I've already told you so many number of times. So you have to remember this one. So sa of t is nothing but sin t by t and the sinc of t is nothing but sin pi t by pi t. So in this case we are going to take the f of t is equal to sin t by t which is equal to sa of t. So I want to represent the picture of this function. So like this we are going to get. So we can say at t is equal to 0, its value is equal to 1. At t is equal to 0, its value is equal to 1. At t is equal to n pi. So substitute at t is equal to n pi. Then what we are going to get? At t is equal to n pi, sin n pi is nothing but 0. So at t is equal to n pi, sin function is nothing but 0. So this function is equal to 0. Then in respect of this value, the overall function is equal to 0 because the numerator is 0 and the denominator is not equal to 0. So overall value is equal to 0. So therefore, at t is equal to n pi, n can be integers. So plus or minus 1, plus or minus 2, plus or minus 3. So the function is going to have the 0 values. At plus 5, minus 5, plus 2 pi, plus minus 2 pi, plus 3 pi, minus 3 pi. The magnitudes are, the magnitude will become 0. Then as t increases, sin function is only going to lie only from minus 1 to plus 1. But as t increases, the denominator is going to get increases. So overall value is going to get decreases. So that is the reason you can see clearly the magnitude value also decreases. The magnitude of the function is going to get decreases. The magnitude of the function is going to get decreases. Is this a periodic signal? No, it's not a periodic signal. Because what is the meaning of periodic signal? Periodic signal means the signal should repeat after a certain period. The waveform should repeat after a certain period. But here, there is no way of repeating because the magnitude is going to decrease further and further. So there is no way of one signal repeating. So definitely we can say this is a non-periodic signal. So we can say simply f of t is equal to sa of t is equal to sin t by t. Here this function is going to become 0 and t is equal to n pi. N is the integers. See, at n pi this function is going to have 0 values and at t is equal to 0 this function is going to give you a value of 1, when you apply the LHospital rule. So now, then, it will have peak, the maximum value of 1, it will have maximum value of 1. As t increases, the interval is going to lie only from -1 to +1, whereas the denominator is going to get increases as t increases, so real value is going to get decreases. That is the reason the function is going to see like a decreasing p. See, sign can, see, as a t is a positive, so t is a positive, right? T is a positive. The sign function can be positive, it can be negative. So because of this, we will have positive as well as a negative. So you can see, suppose if you take only the positive values of t, then what is going to happen? If you take the positive values of the t, then sign function is a positive, and the t is, see, sign function can be positive or it can be negative. It can be positive or it can be negative, but t is always positive. So because of this, you will get sometimes positive, sometimes negative, sometimes positive, sometimes negative. Sign is positive in the range from 0 to pi, and sign is negative from pi to 2 pi. Same thing, from 0 to pi, the sign is positive, so 1 is also positive. From pi to 2 pi, the sign is negative, so 1 is also negative. Again, from 2 pi to 3 pi, the sign is positive, so 1 is positive. From 2 pi to from 3 pi to 4 pi, the sign is negative, so 1 is also negative. And if you see, here f of t is equal to sin t by t, then what is f of minus t? F of minus t is equal to sin of minus t by minus t. So sin of minus t is equal to minus sin theta, minus sin t by minus t. So minus cancel, so you are going to get sin t by t. So this is nothing but f of t. So f of minus t is equal to f of t. So you can say this is real signal. That is the reason this symmetry with respect to y-axis. So this same graph is going to repeat here also because it is a real signal. So finally, you have to remember f of t is equal to saw of t is equal to sin t by t. It is having a maximum value of 1. It is not a periodic signal, and this function is a even signal or symmetric with respect to the axis, and at t is equal to n pi, or n can be affirming integers. This function is going to have 0 values, and as t increases, this function is going to get decreases in magnitude, and sign values only it is going to lie from -1 to +1. As t increases, denominator increases, so overall function is going to get decreases. And also, you can say 0 to pi, sign is positive, so overall is positive. From pi to 2 pi, sign is negative, so overall is negative. From 2 pi to 3 pi, sign is positive, so overall is positive. From 3 pi to 4 pi, sign is negative, so overall is negative. So this is what you have to keep in your mind. So the symmetry to same figure is going to follow here also. That is maximum value is equal to 1, it is going to occur at t is equal to 0. You see, you substitute 0, then what is going to happen? So if you see substitute 0, then sin 0 by 0, sin 0 by 0, sin 0 is equal to 0, so 0 by 0 is indeterminate, so we are going to apply the LHospital rule. Then what is the LHospital rule? It is equal to the limit of the numerator and denominator. So limit t tends to 0, f of t is nothing but the derivative of the numerator and denominator. So limit t tends to 0, which is side derivative is positive and t derivative is 1. So substitute t is equal to 0, then we are going to get cos 0 is equal to 1. So t is equal to 0, this function is going to have a value of 1. So I have already proved here. Then go for the next signal. So what is the next signal that we are going to discuss? Which is sync of t. What is sync of t? Sync of t is nothing but sin of pi t by pi t. I've already told you. Sin of pi t by pi t is nothing but sync t. So if you compare these two things, what we can say? Very simple. So sync t is nothing but saw of pi t. So you can see clearly here, sync t is nothing but saw of pi t. So this is saw of t, right? Saw of t sin t by t. Saw of pi t is sin pi t by pi t, which is nothing but sync t. So we can say clearly. So this is the saw of t. So now I want saw of pi t. Saw of pi t is very simple. I have already told you. Suppose for f of t, if f of t has a time period t, then suppose if its endpoints are, I have already told you, t1 and t2. If it's an endpoints t1 and t2, then f of a has the endpoints. Just divide t1 by a and t2 by a. So here just divide by a. Here what is a? Pi. So just divide by pi for these things. Then what we are going to get? Pi by pi is 1. 2 by pi is 2. 3 by pi is 3. 4 by pi is 4. Like that. So same thing. Just take the numbers now. 1, 2, 3, 4, 5, 6, 7. Minus 1, minus 2, minus 3, minus 4, minus 5. And the graph is same as the previous one. Then the p-value is also equal to 1. We can easily apply the LHospital rule in order to figure this one. So the p-value is nothing but this value is equal to 1. Just we are basically what we are doing, we are either compressing the signal, or whether we are basically pi is nothing but simply we can say pi is nothing but simply pi is greater than 1. Pi is basically greater than 1, right? So pi is greater than 1. So we are compressing the signal. That's it. So here pi is nothing but 3.14 in terms of t. Here 1 is 1. So you can see the signal is basically compressed. Here pi is 3.14. So here this one means whatever the signal, we have compressed it. So this is the compressed form of the previous signal. So this signal is the compressed form of the previous signal. That's it. Just we have compressed the signal. We have not done anything more than that. So we can say for the signal, we can say it is having a maximum value of 1. It is going to apply t is equal to 0. And also this function is going to become 0 at t is equal to, we can say t is equal to 1, t is equal to 2, t is equal to 3, t is equal to 4. So plus or minus 1, plus or minus 2, plus or minus 3. At all these things we can say it is going to have a value of 0. As in, the sign function is going to lie only from minus 1 to plus 1. And as this kilometer is going to get increases, so this overall graph is going to get decreases as time. And it is a non-periodic signal. It is symmetric with respect to y-axis because f of minus t is equal to f of t. So all these things we have discussed, right? So always remember, so of t sin t by t and sinc of t is nothing but sin pi t by pi t. So these things always you have to keep in mind. So then what is, if you compare these two things, we can say sinc of t is equal to sin of pi t. So these things I am trying to tell you. So this signal is the compressed waveform of the previous signal. So now let's go for the other signal, which is the unit ramp signal. So this is a diagram of the unit ramp signal. Its slope is equal to 1. Slope is equal to 1. So you can say this value is 1 and this value is 1. So what is the slope? This value is equal to 0. So you can say at t less than 0, its value is equal to 1. Sorry, t less than 0, its value is equal to 0. And at t greater than equal to 0, it is a straight line with the slope of unity. So r of t is equal to t for t greater than equal to 0. Its value is equal to 0 for t less than 0. So listen carefully. R of t is equal to t for t greater than equal to 0 and its value is equal to 0 for t less than 0. So just remember, r of t is equal to t for t greater than equal to 0 and its value is equal to 0 for t less than 0. So this is the meaning of the unit ramp signal. So always remember, unit ramp signal is nothing but at t less than 0, its value is equal to 0 and at t greater than or equal to 0, it's a straight line passing through origin with a slope of unity. So we can so mathematically we can represent which is r of t is equal to t for t greater than equal to 0 and its value is equal to 0 for t less than 0. Now let's go for the other signal. So this is a signal. So if you see clearly, this is nothing but, so this is nothing but e to the power of et. So this is nothing but only this waveform. Only this waveform is nothing but only this waveform I am trying to tell you. E to the power of at into u of t. E to the power of at into u of t. Then what is this waveform? E to the power of minus at into u of t, right? So why it is like this? Here in this case t is positive. So t is positive, right? Here t is positive means here we should get here minus. So here it's a minus because the decreasing exponential, right? E to the power of minus at u of t is positive, I am going to assume. So then what is going to happen? See clearly. In this range, t is positive, this one t is positive, and a is positive. So this function is going to get decreases. Whereas in this case, so this is u of minus t. For this one, u of minus t will be there. So listen carefully. I will from here. Let me rewrite. E to the power of at into u of minus t. So small connection here. This is a small connection. Let me write this part. So let me write this part so that we can easily able to understand what I am trying to tell you. So this graph is nothing but e to the power of minus at into u of t, and this graph is e to the power of at into u of minus t. So listen carefully here. This is nothing but decreasing exponential. So e to the power of minus at into u of t, area is positive. So at t is positive, so it is going to get decreases. In this case, here t is already negative. So t is negative means already we are going to get negative value of this one. It is going to get decrease. And u of t is negative means u of minus t is equal to positive. So therefore this is a expression of this graph and this is the expression of this graph. So this is the expression of this graph and this is the expression of this graph. So these things always you have to keep in mind. So this is nothing but e to the power of minus at into u of t, and this is e to the power of at into u of t. So listen carefully. What I am trying to tell you. Suppose if you expand this one, it will become like this one. We will expand it. If you expand this part, it will become e to the power of 80, e to the power of 80. It will be e to the power of 80. If you expand like this, totally, it will become e to the power of 80. But I want only up here means e to the power of 80 into u of minus t. U of minus t, because u of minus t will exist from minus infinity to 0. Listen carefully. This total graph is nothing but, this total graph is nothing but e to the power of 80. It is an exponential, e to the power of 80. E to the power of 80. But I want only from minus infinity to 0 only I want. Then I have to multiply by u of minus t, because u of minus t is going to exist for only minus infinity to 0. So if you multiply these two things, then this is a signal that we are going to get. Similarly, if you expand this signal, so if you expand this signal, it will become e to the power of minus 80, 80 you are going to get. So this signal is nothing but e to the power of minus 80. But I want only from t is equal to 0 to t is equal to infinity. So therefore I have to multiply by u of t. Then it will become e to the power of minus 80 into u of t. So finally I can say this signal is nothing but e to the power of 80. So this signal is nothing but, so the total signal is e to the power of 80. But I want only from minus m to 0 means I have to multiply by u of minus t, because u of minus t is going to present only from minus m to 0. So this is nothing but e to the power of 80 into u of minus t. Whereas this one, this total signal is nothing but, this total signal is nothing but, this total signal is it is nothing but e to the power of minus 80. But I want only from t is equal to 0 to t is equal to infinity. So I have to multiply by u of t, because u of t is going to exist only from t is equal to 0 to t is equal to infinity. So e to the power of minus 80 into u of t. So this is what I am trying to tell you. So therefore, this graph is e to the power of 80 into u of minus t, and this graph is e to the power of minus 80 into u of t. So just add these two things in order to get the overall waveform. So f of t is equal to e to the power of minus 80 into u of t plus e to the power of 80 into u of minus t. So how we can write this one in a simple format is equal to e to the power of minus a into mod t. So instead of writing these two things, I will write in a shortcut e to the power of minus a into mod t. See, for t is positive means, for t positive means we are going to get this one. If t is negative means again overall we are going to get positive, then it will become overall negative. So we are going to get this one. So listen carefully. If t is positive means what we are going to get e to the power of minus 80. E to the power of minus 80 we are going to get. If t is positive means power of t is also equal to positive. So therefore, e to the power of minus 80 we are going to get. Suppose t is negative. If t is negative, then so if t is negative means mod of minus t is nothing but again positive. So therefore, e to the power of minus a into t will become minus t. So minus will become positive. So e to the power of 80. So therefore, e to the power of 80. If t is only a positive value, we have to keep here. So therefore, so this is what I am trying to tell you. So therefore, mod t is equal to plus t for t greater than or equal to 0. For mod t is equal to, so mod t is equal to minus t for t less than or equal to 0, because t is less than or equal to 0. So in subsidiary, so in subsidiary we are going to get minus of minus is nothing but positive. Same thing for t greater than 0, I have replaced mod t by plus t. Then I have got e to the power of minus 80. I have got for t less than 0, then what I have substitute mod t is equal to minus t. Then it will become e to the power of 80. E to the power of 80. But t is less than 0. T is less than 0. So we are going to get this graph. This is what I am trying to tell you. This is what I am trying to tell you. So mod t is equal to plus t, for t greater than or equal to 0, and mod t is equal to minus t, for t less than or equal to 0. So this is what I am trying to tell you. So for t greater than 0, replace mod t by t, then we are going to get e to the power of minus 80. This is what we are going to get. And for t less than or equal to 0, replace mod t by minus t, and if we simplify, we are going to get e to the power of 80. E to the power of 80 for t less than 0. This is what we are going to get. So this is what this is a simple representation. This is a simple representation of writing these two things. I have used it in a very simple manner. Now let's go for the another signal, which is signal function. The signal function of t is nothing but u of t minus of u of minus t. This is called the signal function. This is called as the signal function. Signal function. F of t is equal to signal function is sgn of t, or you can call signal function is u of t minus of u of minus t. So this is nothing but u of t, right? So this is u of t, and this is nothing but minus of u of minus t. So add these two signals, then you are going to get the signal function. So therefore, signal function is equal to u of t minus of u of minus t. So therefore, what is a signal function? Signal function is nothing but u of t minus of u of minus t. So this is nothing but u of t, and this is minus of u of minus t. So add these two things in order to get the function f of t. So f of t is a signal function which is equal to u of t minus of u of minus t. So this is the we can say mathematical way of representing this waveform. So this is u of t and this is minus of v of minus t. So if we have these two things, we are going to get the overall function f of t, which is called as the signal function. So these things always you have to keep in your mind. So now we are going to discuss another concept, which is the unit impulse signal. So we are going to study in detailed manner regarding the unit impulse signal. So we are going to do a very detailed analysis of the unit impulse signal. So what is the meaning of unit impulse signal? I have already told you delta of t. It is having a unit area at t is equal to 0. So at t is equal to 0, it is having a unit area. It is basically having a unit area. Area is equal to 1. If you want to mathematically represent, I have already told you delta of t is equal to 0 for t not equal to 0, and its value is equal to infinity. The magnitude value is equal to infinity at t is equal to 0. Now we can say not equal to 0 at t is equal to 0. Now if I have already told you, always we are going to represent the impulse response in the terms of the area. So the area of the impulse function is equal to a is equal to 1. So here I am going to represent the delta of t with a further analysis. Suppose let me take a simply f of t. So let me say a rectangular pulse of something. Let me take f of t. So here it is having a width here minus a by 2, area by 2, and its peak value is 1 by a. So what is like this? Let's see here. So what is the width here? A by 2 plus a by 2, which is a, and it should be 1 by a. Then the area is equal to 1. So let me take another rectangular pulse. Here the width is now, how much the width here? This a by 4 and this a by 4, this a by 2. So here it should be 2 by a. Then the area is equal to 1. So it's having a peak of 2 by a. Area is equal to 1. Let me take the another signal, rectangular pulse p of t, which is having a width of a by 8 and a by 8 means a by 8 plus a by 8 is equal to a by 4. So the height will be 4 by a. Then the area is equal to 1. So let me go for the other signal q of t, which is basically rectangle, like a triangle pulse. Triangle pulse I am going to take here. So for a triangle, what is the area? Area is called half into basic, right? Half into what is base? Base is something like 2a. Height is something like 1 by a. So if you simplify half into 2a into 1 by a, how much you are going to get? 2 cancels, a cancels. You are going to get area is equal to 1. Similarly, let me take the another rectangular pulse m of t. Here the width is a and the height is 1 by a. Then area is equal to 1. So these are the different rectangular pulses and triangular pulses I have taken, and I have showed you the corresponding area. For all these pulses, the area is equal to 1. The area is equal to 1, as you can see clearly here. So what I have did, area is equal to 1. I have already shown you. I have shown you clearly for all these pulses. I have given the area is equal to 1. So now what is going to happen? Let's see one after the other. So now I want to find what is the differentiate of the signal. So I want to find what is the differentiation of the signal I want to figure out. So f of the derivative I want to figure out. So we can see what is the derivative here. It will become what is the height? It is going to get increased. So it is going to increase by 1 by a. So it will become 1 by a. And it will become a. It is having an area of 1 by a. And here it is a constant, right? So division will become 0. For a constant signal, that division is equal to 0. Again decreasing. How much it is going to decrease 1 by a? So now downward the area of minus 1 by a. So here you can see it is a constant, right? So division is equal to 0. Sudden rise means positive, sudden decay means negative. So how much sudden rise? It is raised by 1 by a. So area is equal to 1 by a. It is decreased by how much unit? 1 by a. So decreased means minus, so minus 1 by a. Similarly, for just g of t, I want to find what is the differentiation. So you can see there is a sudden rise from there is sudden rise by 2 by a and minus a by 4. So minus a by 4, there is a sudden rise. This impulse signal of area 2 by a. Again, it's a constant, right? So the division is equal to 0 for constant. The division is equal to 0. Again at a by 4, there is a sudden decay. So sudden decay by how much? 2 by a. So therefore, there is a sudden decay means downward. So downward area of minus 2 by a. Similarly, what is P of t? What is differentiation? So at minus a by 8, there is sudden rise by 4 by a. So at minus a by 8, the area having an impulse, there is an impulse of area 4 by a plus 4 by a. So this is a constant. So differentiation of constant is equal to 0. Again there is a sudden decrease by 4 by a at a by 8. So a by 8. Sudden decay, so sudden decrease. So there is a negative impulse of area minus 4 by a. Similarly, Similarly, there is a triangle, right? So for this triangle, if you see, I want to find the differentiation of this one. So this is basically a straight line with constant slope. So differentiation is basically slope. What is the slope here? This is 1 by a and this is a. So slope is equal to plus 1. So slope is equal to plus 1. So we can say here, what is the slope here? 1 by a and a. 1 by a is nothing but 1 by a square. So slope is 1 by a square. So from minus a to 0, the slope is 1 by a square. From 0 to plus a, I want to find this is the straight line. So what is the slope? Decreasing the slope will be negative. So this is how much? 1 by a and this is a. So minus 1 by a square. Minus 1 by a square. So minus 1 by a square from 0 to a. Increasing means positive slope, decreasing means negative slope. Simple thing. So negative decreasing means negative slope. By also the x-axis, minus 1 by a square. Minus 1 by a square. Increasing means positive slope, decreasing means negative slope. And increasing means positive slope, decreasing means negative slope. Increasing means positive slope, decreasing means positive slope. Same thing I have taken here. For this rectangular pulse, I want to find the differentiation of this into m of t. So it will become m dash of t. So if you see clearly, here, sudden rise from 0 to 1 by a. This is sudden rise by 1 by a. So there is a impulse of area 1 by a at t is equal to 0. And here, the constant rate, so differentiation of constant is equal to 0. Again, at a, there is a sudden decrease by 1 by a. So the differentiation to become a negative impulse of area minus 1 by a. Minus 1 by a. So downward impulse of area minus 1 by a. As you can see clearly here. So for all these signals, f of t, g of t, p of t, q of t, and m of t, I have figured out the differentiation also. Now, what is the meaning of this one? We will see here. Suppose if you take a to 0, then what is going to happen? For all the signals f of t, g of t, p of t, q of t, and m of t, if you make a tends to 0, then what is going to happen? If a tends to 0 means this 50 is going to get decreases and I will increases, and still there is equal to 1. So all the signals, if limit a tends to 0 for f of t, g of t, p of t, q of t, m of t, then all these are going to tend to delta of t. So the same thing I will take limit a tends to f of t, or limit a tends to 0 g of t, or limit a tends to 0 p of t, or limit a tends to 0 for q of t, or limit a tends to 0 for m of t. All these are going to give you delta of t. So if you make this the limit a tends to 0, all the signals are going to become delta of t. That is what I am trying to tell you. Similarly, then what this will become, what this will become. Suppose for this definition also, if you make a tends to 0, then what is going to happen? Suppose if a tends to 0 means this will come here and this will come here. So it will be so a tends to 0 means what is going to happen? Area is equal to infinity, area is equal to mass infinity. So you can see clearly all these are going to coincide like this. So you see, for this one, if you make a tends to 0, all are going to come in this manner, right? At t is equal to 0, we are going to get a big impulse of area. One we have got. For this differentiation, if you make a tends to 0, then what is going to happen? This comes this one in this direction, upward direction. This comes in the downward direction. For all these things, for all these things, for all these things. So then what is going to happen? Then a tends to 0 means 1 by 0 is nothing but plus infinity. Mass of 0 is nothing but minus infinity. So therefore, upward there is an area of a is equal to plus infinity. Downward there is another pulse of area is equal to minus infinity. So if you tell me a tends to 0 for a dash of t, g dash of t, p dash of t, and q dash of t, and m dash of t, all these are going tends to this delta dash of t, delta dash of t. So this is what I am trying to tell you. So limit a tends to 0 f dash of t, limit a tends to 0 g dash of t, limit a tends to 0 p dash of t, and limit a tends to 0 q dash of t, and limit a tends to 0 m dash of t. All these are going to give you delta dash of t. So this is the delta of t and its derivative. So you can see here also same thing. If a tends to 0, then what is going to happen? This will become plus infinity area, and this will become minus infinity area at t is equal to 0. See, this also at t, if substitute a is equal to 0, this will become area of infinity, and this will become area of minus infinity. And a tends to 0 means it will come here only. This is what I am trying to tell you. So finally, I can say delta of t. So this is a graph, and delta dash of t. This is a graph that we are going to get. So this is basically understanding. So the way of understanding the delta of t and delta dash of t. So if I say delta t and delta dash of t will be like this means for delta of t, no one will understand. So suppose I have showed you delta, suppose if I say delta of t this one and delta dash of t this one, no one will understand. So that is the reason I have given so much signals. Then I have made the corresponding deposition I have made here, and then I repeat and I have made limit a dash to 0. Then all this one became this one. As well, if I make a dash to 0, all this one has become this one, right? So therefore, this is the delta dash of t. So therefore, delta of t is the thing that it is having a impulse at t is equal to 0 with area is equal to 1. Where here delta dash of t is the thing that at t is equal to 0, it will have positive impulse of area is equal to infinity, and there is a negative impulse of area which is area is equal to minus infinity. So this is what I am trying to tell you. So delta of t is the thing that there is a impulse of area unity at t is equal to 0, and delta dash of t is the thing that there is an impulse of area at t is equal to 0. There is an impulse of area plus infinity as well as a minus infinity. So therefore you can say clearly delta of t is the thing that at t is equal to 0, there is an impulse of area is equal to 1, and delta of dash of t is the thing that there is a positive impulse of t is equal to 0 with area of plus infinity. There is a negative impulse of area at a minus infinity at t is equal to 0. So this is what I am trying to tell you. So these things always you have to keep in mind. When limit a dash to 0, all these are going to coincide with delta of t, and when a dash to 0, all these are going to coincide with delta dash of t. So this is what I am trying to tell you from this one. So finally I can say delta of t is nothing but at t is equal to 0, there is an impulse of area, a unity, and delta dash of t is nothing but at t is equal to 0, there is a positive impulse of area infinity, and there is a negative impulse of area minus infinity. So these things always you have to keep in your mind. Now we are going to discuss the another new concept, which is basically the eigenfunctions for the LTI systems. So we are going to learn about the eigenfunctions for the LTI systems. We are going to learn in a very detailed manner. So let me take a system which is called as the LTI system. It is going to satisfy the two properties, linearity as well as the time invariant. So that is the reason we say the system is said to be linear time invariant. And I am going to assume for this LTI system impulse response, I am going to assume h of t is equal to a into delta of t. So here I am going to assume the impulse response of the system is nothing but which is h of t is equal to a into delta of t. So whenever h of t is equal to a into delta of t, we can say this is said to be static system, right? So whenever the impulse response is equal to a into delta of t, we say it is basically a static system. I want to draw this point. So now suppose for the system, if I am going to give the input as f of t, then what is the output? And what is the output? See, so output is nothing but y of t. Y of t is f of t convolution of a into delta of t. So a is a constant, we can take it outside. So a bracket of f of t convolution of delta of t is nothing but again f of t. So what is the output here? A into f of t. So therefore the output that we are going to get is a into f of t. So here if you see, input is f of t and the output is a into f of t. So we can say that the only thing is the output is the scaled version of the input. So the output is the scaled version of the input. So therefore we can say for this LTI system, if the impulse response is h of t is equal to a into delta of t, so if we are going to give the input is f of t, then output is a scalar multiple a times f of t. So therefore whenever you are going to give input as f of t, the output you are going to get a into f of t, which is scalar multiple of the input function f of t. So this is the output that you are going to get. Now let's go for the another system. So let's go for the another LTI system. Design the impulse response h of t is equal to a in delta of t minus t naught. So for this LTI system, the impulse response h of t is equal to a into delta of t minus t naught. So now if I am going to give the input as f of t, then what is the output? Output I am going to assume y of t. So y of t is equal to f of t convolution of a into delta of t minus t naught. A is a scalar quantity, we can take it outside the convolution. So a bracket of f of t convolution of delta of t minus t naught. So then what you are going to get? Basically f of t minus t naught you are going to get, and what I told you, the basic formula, f of t minus t1 convolution of delta of t minus t2 is equal to f of t minus of t1 plus t2. So based on this property, we are going to get the solution. The output is a into f of t minus t naught. So always you have to remember the basic formula as I already told you so many number of times. So let me write this formula again so that you can able to remember. So these properties always you have to keep in your mind. So f of t minus t1. F of t minus t1, convolution of delta of t minus t2 is equal to f of t minus of t1 plus t2. So these things always you have to keep in mind. So these things always you have to keep in mind. So therefore, we can say with the help of this formula, we have got this. So this a into f of t minus t1. So for this LTI system, it's having impulse response. H of t is equal to a into delta of t minus t0. If the input is f of t, then we are going to get the output which is a into f of t minus t0. Similarly, for the other LTI system, suppose if you take some LTI system, for this LTI system, let me assume the impulse response is h of t, and if the input is e to the power of j omega naught t, then what is the output, which is e to the power of j omega naught t into h of j omega naught, h of j omega naught. So here, for this LTI system, the impulse response is h of t. If the input is e to the power of j into omega naught t, the output is e to the power of j into omega naught t into h of j omega naught. So basically, what is the meaning of eigenfunction? Eigenfunction is nothing but if you are going to give certain input, the output is a scalar multiple of that input, then that functions are called as the eigenfunctions. So listen carefully. Suppose you take some LTI system. For the LTI system, you give some input, and if the output is a scalar multiple of that input, then that inputs are called as the eigenfunctions for the LTI system. So listen carefully. If you take an LTI system, and if you give certain input, then the output is if the output is a scalar multiple of that input, then we can say that input is said to be eigenfunction for the LTI system. So you can see clearly your input is f of t, so output is a scalar multiple of input. So we can say this is called as the f of t is called as eigenfunction for this input. Similarly, if the input is e to the power of j omega naught t, the output is e to the power of j omega naught t into h of j omega. H of j omega is a constant. We can say it's a complex variable, but it's a constant. So therefore, but here input times is some scalar multiple. So therefore, the output is a scalar multiple of the input. So therefore, e to the power of j omega naught is also eigenfunction for this LTI system. So this is what I am trying to tell you. So basically, what is y of t? So you know the y of t formula. So you suppose for this one I am going to analyze. So you know the basic formula, right? So y of t, you know the basic formula. So what is the? I've already told you. Suppose if the input is f of t, and the impulse response is h of t, then what is the convolution? You can write like this: 2 is equal to minus infinity to plus infinity f of 2 into h of t minus 2 into d2. Or you can write in the reverse fashion also, which is integration from 2 is equal to minus infinity to plus infinity h of 2 into f of t minus 2 into d2. So you can write it anything. So in this way, basically we are going to use this formula. So we are going to use this one, which is h of t is h of 2. In place of t, substitute 2, h of 2. And here f of t is nothing but e to the power of j omega naught t. But I want f of t minus 2. So here this is f of t, right? So here f of t is nothing but e to the power of j omega t. So f of t is equal to e to the power of j omega naught t. So in place of t, substitute t minus 2, we are going to get e to the power of j omega naught of t minus 2 into d2. So 2 is varying from minus infinity to plus infinity. So if you simplify, see basically we are doing with respect to integration from 2 is equal to minus infinity to plus infinity we are doing. So definitely t is a constant, so we can take it outside. So therefore we are going to get e to the power of j omega naught t into integration from 2 is equal to minus infinity to plus infinity h of 2 into e to the power of minus j omega naught tau d2. So this is called as the Fourier transform. So this is called as a Fourier transform of the. So this part is called as a Fourier transform of the impulse response of the h of t impulse response, which is h of t. So therefore this is called as a h of j omega naught. We can write here h of j omega naught. So y of t is nothing but e to the power of j omega naught t into h of j omega naught. So therefore we can say this is a complex number. So complex way is a complex number. So this is a complex number finally you are going to get. So this is nothing but h of j omega naught, or we can write h of j omega naught, you can write. Sometimes some books they will write h of omega naught also they will write. It is up to you. Whatever you think and it is same. Basically it is a complex number. So therefore we can say that I already told you what is the meaning of eigenfunction. If the input is f of t, then the output is scalar multiple of the input, then those inputs are called as the eigenfunctions for those LTI systems. So we can say e to the power of j omega naught is the eigenfunction for the LTI system. F of t is also eigenfunction for this LTI system, as you can see clearly from this one. So this is called as the Fourier transform of the impulse response h of t. So these things always you have to keep in your mind. So now we will go for the further analysis. Here, if you see clearly, here h of t. So basically, let me do some more analysis. So you take the LTI system. The LTI system is having the impulse response h of t. The LTI system is having the impulse response h of t. If the input is x of t and the output is y of t for this LTI system. So we can see for this LTI system which is having the impulse response h of t, the input is x of t and the output is y of t. So I can write x of t like this. Sigma n is equal to minus f to plus f to Cn e to the power of j f omega naught t. So I can write like this x of t. So basically in the previous class, in the previous lecture what we have discussed, there we have written x of t in the terms of impulse response. But here the impulse signal, there we have written x of t in terms of impulse signal. But here we are going to write in the exponential terms we are going to write. So sigma n is equal to minus m to plus m to Cn e to the power of jn omega naught t. So like this we can write. And what is y of t? Y of t is equal to sigma n is equal to minus m t to plus m to Cn. See, I already told you, because it's the LTI system. LTI system means linearity is going to get satisfied and time invariant is also going to get satisfied. So Cn will become same Cn and the sigma will become same sigma. And I've already told you, e to the power of j omega naught t, this is the input, right? Same thing you are going to get e to the power of jn omega naught t, but only thing is now we are going to get h of jn omega naught. So with the help of previous concept. So therefore we can say that this is what that we are going to get finally. So with the help of LTI system, linearity as well as the time invariant. So linearity means the input is the summation of two previous inputs, the output is the summation of two previous outputs, and time invariant means if the input is delayed by some amount of time, the output is also delayed by the same amount of time. So with that x of t is equal to sigma n is equal to minus m to plus m to Cn e to the power of jn omega naught t. So output y of t is equal to sigma will be same, sigma n is equal to minus m to plus m to Cn will be same. And I already told you, if the input is e to the power of, I already told you, suppose what is the input is e to the power of j omega naught t, then what is the output that we are going to get? E to the power of j omega naught t into h of j omega naught. Suppose if the input is e to the power of j n omega naught t, then what is the output we are going to get? E to the power of j n omega naught t into h of j n omega naught. Same thing we have written. So a plus of e to the power of j n omega naught t the input. Then what is the output? E to the power of j n omega naught t into h of j n omega naught. So this is what I am trying to tell you. So here e to the power of j omega naught t or e to the power of j n omega naught t is the eigenfunction for the LTI system, because the output is a scalar multiple of the input. So like this we can write here. So now let's go for the further analysis. So for this discrete time, so up to now we have discussed about the continuous time domain. Now let's go for the discrete time domain. So this is the LTI system. For the LTI system, the impulse response is h of n and the input is x of n, so output is y of n. Suppose if the input x of n is equal to e to the power of j omega naught n plus of t, I have kept here n, that's it. So then what is the y of n? Y of n will be e to the power of j omega naught into h of j omega naught. So these things, just in place of t substitute n, that's it. We are going to get the same thing, right? Then h of j omega naught is nothing but here the Fourier transform will be different. The discrete time domain is different and continuous time domain which is different, which is sigma k is equal to minus m to plus m t h of k into e to the power of minus j omega naught k. This is for the discrete time domain and this is for the continuous time domain. So finally, let me give the conclusion so that we can easily able to understand. So listen carefully. Suppose for the continuous time domain, I am going to tell you, suppose if the input is e to the power of j omega naught t, then what is the output we are going to get, which is e to the power of j omega naught t into h of j omega naught. Suppose if the input is e to the power of j n omega naught t, then what is the output we are going to get? E to the power of j n omega naught t into h of j n omega naught. I already told you what is the Fourier transform of h of t. So Fourier transform of h of t, I already told you, which is h of we can say that h of j omega naught. We can say h of j omega naught. or simply we can say h of omega naught also we can write anything which is same, which is equal to, we can say integration from tau is equal to minus infinity to plus infinity h of tau into e to the power of minus j omega naught tau d tau. So these things always you have to keep in your mind. So therefore, you can say h of, either you can write j omega naught or h of omega naught also you can write. This integration from tau is equal to minus infinity plus infinity h of tau into e to the power of minus j omega naught tau d tau. So this is for the continuous time case. Now let's go for the discrete time case. So discrete time case I am going to give you. Suppose if the input is e to the power of j omega naught n, then what is the output? E to the power of j omega naught n, h of j omega naught, just you can write omega naught. It's a complex number. Similarly, e to the power of j n, see here we don't have to take this one. So let me go for k. E to the power of j k omega naught n. Then what it will be? E to the power of j k omega naught n into h of j k omega naught. So this you can see clearly right here. Then what is the Fourier transform in the case of discrete time domain h of j omega naught, or we can write h of omega naught we can write, which is equal to k into which it will become sigma. The term is k is equal to minus infinity to plus infinity h of k into e to the power of minus j omega naught k. That's it. So therefore, these things always you have to keep in mind. So finally, this is for the continuous time case and this is for the discrete time case. So listen carefully. For the continuous time case, if the input is e to the power of j omega naught t, the output is e to the power of j omega naught t into h of j omega naught, or you can write h of omega naught also you can write. Suppose if the input is e to the power of j n omega naught t, the output is e to the power of j n omega naught t into h of j n omega naught or h of n omega naught. You can write anything. Anyhow, it is a complex number. So if you want to know what is the Fourier transform of the impulse response, then the impulse response, which is h of j omega naught and h of omega naught, is equal to integration from tau is equal to minus infinity to plus infinity h of tau into e to the power of minus j omega naught tau d tau. Basically here they have used omega naught because the frequency of omega naught. Suppose if you want general expression means e plus omega naught by omega, then you are going to get the general expression. Then for the discrete time domain, if the input is e to the power of j omega naught n, the output is e to the power of j omega naught n into h of j omega naught, or you can write h of omega naught. If the input is e to the power of j k omega naught n, and the output is e to the power of j k omega naught into j k omega naught n into h of j k omega naught or h of k omega naught. You can write it anything. Then what's the Fourier transform of the impulse response in the discrete time domain? H of j omega naught or h of omega naught is equal to sigma k is equal to minus infinity plus infinity. Your term is it will become k. Your integration means it will become sigma. H of, in terms of k we are writing that, so h of k into the power of minus j omega. Tau is nothing but k here. So replace tau by k and replace integration by sigma. That's it. You are going to get this value. So replace integration by sigma and replace tau by k. That's it. You are going to get this expression. So if you remember the Laplace transform, then you can get the Fourier transform. So I already told you for f of t, what is the Laplace transform? It is equal to f of s is equal to, simply we can say integration from t is equal to minus infinity to plus infinity f of t into e to the power of minus st into dt. So this is the Laplace transform. Suppose for f of t, if you want the Fourier transform, so Fourier transform is f of omega. So if you want Fourier transform, replace h by j omega, that's it. So t is equal to minus infinity to plus infinity f of t into e to the power of replace h by j omega. So j omega t dt. That's it. So same thing I have told you, same thing. Basically they have used t, they have used tau. Here t is a dummy variable. You can use tau, then you can use t, and here it is a dummy variable. Suppose for h of t, if you want to find the Fourier transform. So for h of t, if I want to find the Fourier transform, then I can write h of omega. I can write h of omega. H of omega is equal to integration from, either you can use t is equal to minus into plus infinity h of t into e to the power of minus j omega t into dt. Either you can use t or either you can use tau, anything which is same. But here the input is having the frequency of omega naught. So that is the reason I have replaced omega by omega naught. The general expression is like this. So this is a Fourier transform. If you remember the Laplace transform in case of JSC, if you substitute j omega, we are going to get the Fourier transform for a given signal. For a given signal. Sometimes they use f of j omega, or sometimes they use f of omega. Anyhow, it is a complex number, right? So these things always you have to keep in your mind. So like this always you have to analyze. Now we'll discuss the one more important concept. Suppose let me take a LTI system. So let me take a LTI system. Yes, before this LTI system, the impulse response is h of t. The impulse response is h of t. And if the input is x of t, and the output is y of t for this LTI system. So for this LTI system, the impulse response is h of t, and the input is x of t, and the output is y of t. Suppose I am going to write a input x of t in the format of exponential terms like this: c1 into e to the power of j omega 1 t plus c2 into e to the power of j omega 2 t plus c3 into e to the power of j omega 3 t plus c4 into e to the power of j omega 4 t. So like this I am going to write. So in the basically in the previous classes what we have learned, there we have written the x of t in the terms of the impulse signal, but here we are going to write the x of t in the terms of the exponential terms. So this is the only thing that you always have to keep in your mind. So there the basic signal is the impulse signal. Here the basic signal is the exponential signal. So this is what I am trying to tell you. So therefore there the basic signal is delta of t. Here the basic signal is e to the power of j omega t. So there input x of t are written in the terms of delta of t. Here I am going to write the x of t in the terms of e to the power of j omega t. So this is the only thing that I am trying to tell you. So therefore I am going to write x of t like this: c1 into e to the power of j omega 1 t plus c2 into e to the power of j omega 2 t plus c3 into e to the power of j omega 3 t plus c4 into e to the power of j omega 4 t. Then what is the output? Output is nothing but it is going to satisfy the linear time invariant. So it is going to satisfy the two properties, linearity and the time invariant. So linearity means I have already told you c1 is same c1 into, if the input is e to the power of j omega 1 t, then what is the output? E to the power of j omega 1 t into h of j omega 1, or you can write h of omega 1 also you can write, plus c2 into e to the power of j omega 2 t into h of j omega 2 or h of omega 2 also you can write, plus c3 into e to the power of j omega 3 t into h of j omega 3 or h of omega 3 also you can write. Then c4 into e to the power of j omega 4 into h of j omega 4. So in this way we can get the output, because it is going to satisfy the linearity means here plus means here plus, here plus means here plus, here plus means here plus, and same constants here you are going to get. If the input is e to the power of j omega t, then what is the output? E to the power of j omega t into h of j omega. This one I already told you. So with the help of this concept, so this is the output we are going to get. So this is the output. Then what is the Fourier transform of the impulse response? I have already told you. So suppose for h of t, suppose this is the h of t. So for h of t, what is the Fourier transform? The Fourier transform is I have already told you. H of omega we can write, which is equal to integration from t is equal to minus infinity to plus infinity h of t into e to the power of minus j omega t into dt. So here you can take t the dummy variable, right? So t the dummy variable, either you can use t or either you can use tau. So some textbooks they are going to use h of omega, or some textbooks they are going to use h of j omega. Is equal to integration from tau is equal to minus application of the h of tau into e to the power of minus j omega tau into d2. See, in place of t I substitute here tau, and here j omega, sometimes they will write h of j omega, h of omega or h of j omega. It is a standard notation, you can use anything. So this is a Fourier transform of the impulse response. So if you want omega 1 means replace omega by omega 1. If you want omega 2 means replace omega by omega 2. If you want omega 3 means replace omega by omega 3. If you want omega 4 means replace omega by omega 4. That's it. So this is the thing always you have to keep in your mind. So now let's go for some important note. So some important note we are going to discuss in a very detailed manner. So for a static LTI system, having an impulse response h of t is equal to a in the delta of t, any general signal f of t can be defined as its eigenfunction. Listen carefully. For a static LTI system, having the impulse response h of t is equal to a in the delta of t, any general signal f of t can be defined as its eigenfunction. I have already told you this concept. Suppose if you are taking an LTI system which is having the impulse response h of t is equal to a in the delta of t, so definitely we can say it's a static system. No matter whatever the input, always the output is, the input is f of t for this LTI system, the output is a into f of t means whatever the input can be anything, for this LTI system, the output is a scalar multiple of the input. So we can say the f of t is called as the eigenfunction for this LTI system. So for a static LTI system, having the impulse response h of t is equal to a into delta of t, any general signal f of t can be defined as its eigenfunction. So finally, I can say if you are taking suppose if you are taking an LTI system which is having the impulse response h of t is equal to a into delta of t, so basically it is a static LTI system. So then, no matter whatever the input you are going to get, the output is always a scalar multiple of that input. So therefore, that is a property of the eigenfunction. If the input is any, if you are going to give some input, the output should be a scalar multiple of that input. Then only we can say that the input is called as eigenfunction for that system. So here we can say f of t is said to be the eigenfunction because it's going to satisfy that property. So now the next statement is LTI system having an impulse response h of t is equal to a into delta of t minus t naught, and any signal which is periodic with a period t naught can be defined as its eigenfunction. So then carefully, LTI system having an impulse response h of t is equal to a into delta of t minus t naught, and any signal which is periodic with the period t naught can be defined as its eigenfunction. I have already told you, suppose if you are taking an LTI system which is having the impulse response h of t is equal to a into delta of t minus t naught, then if you are going to give the input as f of t, then what is the output, which is a into f of t minus t naught. Suppose if you are taking f of t as a periodic signal with a period of t naught, then f of t minus t naught is nothing but f of t naught only. So f of t only. So therefore, here the output is a scalar multiple of the input. So we can say it is a scalar, it is a eigenfunction. So what I am trying to tell you is very simple. Suppose for a given LTI system, if the impulse response is h of t is equal to a delta of t minus t naught, and if you are going to give certain input f of t, then what is the output? The output is a into f of t minus t naught. Suppose f of t is also periodic signal with a period of t naught, then f of t minus t naught is equal to f of t only. So therefore, what we can say, then we can see the output is a scalar multiple of the input. So therefore, what we can say, suppose if a system is having an impulse response a into h of t is equal to a delta of t minus t naught, then all the periodic signals with a period of t naught are said to be the eigenfunctions for this LTI system. Listen carefully. Suppose there is some LTI system. For this LTI system, the impulse response h of t is equal to a into delta of t minus t naught. Then, if you are taking an input which is a periodic signal, a period of t naught, then we can say that is called as the eigenfunction. So all the periodic signals of period t naught are called as the eigenfunctions for this system. So this is what I am trying to tell you. So therefore, the LTI system having an impulse response h of t is equal to a delta of t minus t naught, and any signal which is a periodic with a period t naught can be defined as its eigenfunction. So these things I have already clearly explained. So if you're taking an LTI system, if its impulse response is equal to h of t is equal to a into delta of t minus t naught, so if you are going to give certain input f of t, the output is a into f of t minus t naught. And if we are taking if you are taking the input as a periodic signal to the period of t naught, then f of t minus t naught is equal to f of t. So therefore, we can say all the periodic signals of period t naught are called as the eigenfunctions for this corresponding system having the impulse response h of t is equal to a into delta of t minus t naught. So now the next point is, for any LTI system, irrespective of the nature of its impulse response, a phasor can be defined as its eigenfunction. So we can say for any LTI system, irrespective of the nature of its impulse response, a phasor can be defined as its eigenfunction. I already told you, suppose if you are taking an LTI system, of its impulse response h of t, and if the input is e to the power of j omega t, then what is the output, which is equal to e to the power of j omega t into h of j omega. So h of j omega is a constant, it's a complex constant. So the output is a constant of the input. So therefore we can say it is also coincides with the property. So therefore we can say that the exponential terms are called as the eigenfunctions for this corresponding system. So for any LTI system, irrespective of the nature of the impulse response, a phasor means e to the power of j omega t, that can be defined as its eigenfunction. So let me finally conclude this concept with the help of by seeing this picture. So you can see clearly for this first LTI system, this LTI system is having the impulse response h of t is equal to a into delta of t. No matter whatever the input, the output is always the scalar multiple of the input. So this anything of input can be represented as the eigenfunction for this system. Suppose for another LTI system is having the impulse response h of t is equal to a into delta of t minus t naught, and here only the periodic signals to the period of t naught are called as the eigenfunctions for this system. And suppose if you take an LTI system with any impulse response h of t, and if the input is a phasor, means e to the power of j omega t, then the output is always the scalar multiple of the input. So therefore we can say that the phasor of the exponential terms are called as the phasor terms are called as the eigenfunctions for this system. So this is what we are going to get concluded. So these 3 points are very much important. These 3 points are obtained from that concept. So these things always you have to keep in your mind. So now let's go for the other concept, which is the trigonometric Fourier series. So we are going to learn somewhat in detail analysis regarding the trigonometric Fourier series. So these things always you have to keep in your mind, because the trigonometric Fourier series is very, very important. So that is what I am going to discuss in a very detailed manner. So here, what is a f of t? See, any periodic signal we can represent in the form of sin and cos, like this. F of t is equal to a naught plus sigma n is equal to 1 to infinity a n cos n omega naught t plus b n sin n omega naught t, where omega naught is equal to the fundamental frequency. Omega naught is equal to 2 pi by t naught. 2 pi by naught. Where t naught is the fundamental time period and omega naught is the fundamental frequency. So f of t is equal to a naught plus sigma n is equal to 1 to infinity a n cos n omega naught t plus b n sin n omega naught t. So this formula always you have to keep it in mind. So this is a expression. So if a signal is periodic, then this is a way we can represent the terms of sin and cos, which is f of t is equal to a naught plus sigma n is equal to 1 to infinity a n cos n omega naught t plus b n sin n omega naught t. So f of t is equal to a naught plus sigma n is equal to 1 to infinity a n cos n omega naught t plus b n sin n omega naught t. So f of t is equal to a naught plus sigma n is equal to 1 to infinity a n cos n omega naught t plus b n sin n omega naught t. Omega naught is equal to 2 pi by t. T or t you can call it, t naught you can call. Omega naught is equal to 2 pi by t, but t is the fundamental time period of the periodic signal. So always remember, any periodic signal we can represent in the form of sin and cos, which is f of t is equal to a naught plus sigma n is equal to 1 to infinity a n cos n omega naught t plus b n sin n omega naught t, where omega naught is the fundamental frequency, which value is equal to 2 pi by t, that t is the fundamental time period. Then I will do some simplification of this one. Listen carefully. I will try to do some simplification of this one. So listen carefully. Here a n cos n omega naught t plus b n sin n omega naught t, I will write in terms of cos. So I will write in terms of cos. How we can write cos means, you see, Rn cos of n omega naught t minus pi n. So I am going to write in terms of like this. So why it is like this? You see, if you expand what you are going to get, cos of a minus b is equal to cos a cos b plus sin a sin b, right? So therefore, what you are going to get, Rn into cos omega naught t into cos of phi n plus Rn into sin n omega naught t into sin pi n, right? So cos a cos b plus sin a sin b. So taking Rn inside. So this is what we are going to get. So then if you see clearly, then here Rn into cos phi n is nothing but an, right? So if you compare, Rn into cos phi n is nothing but an. So if you see clearly, then what we can say, the Rn into cos phi n is nothing but jn. Then Rn into sin phi n is nothing but bn, right? Bn, comparing. Then what I will do, I will do squaring of the both sides, LHS and RHS. And if I simplify, then I am going to get, see, first equation I will do square on both sides, second equation I will do squaring on both sides, then I will add these two terms, and what I am going to get, Rn square is equal to an square plus bn square, right? Then what is Rn? Rn is equal to under root of an square plus bn square, right? So same thing I have got. Then what I will do, I will basically divide the second equation with first equation. Then what I am going to get, sin phi n, Rn cancels. So sin phi n by The cos phi n is nothing but tan phi n. So tan phi n is equal to Bn by An we are going to get. And what is phi n? Phi n is equal to tan inverse of Bn by An. So this is what I am trying to tell you. So therefore, here, these things I am going to write in terms of Rn into cos of n omega naught t minus phi n. So here cos A minus B is equal to cos A, cos B plus sin is sin B. So then what I am going to get? Rn into cos n omega naught t into cos phi n plus Rn into sin n omega naught t into psi n. So by comparing these two things, we can say Rn into cos phi n is equal to Bn, Rn into sin phi n is equal to Bn. So this is the equation and this is the equation 2. So I am going to do the squaring on the both sides, equation 1 and equation 2, and I will add these two equations. Then we are going to get Rn square is equal to An square plus Bn square. So Rn is equal to under root of An square plus Bn square. So now I will do the divide the equation 2 by equation 1. Then we are going to get R and R cancels. So tan phi n is equal to Bn by An. So phi n is equal to tan inverse of Bn by An. So therefore we can say An cos n omega naught t plus Bn sin n omega naught t. We can write Rn cos of n omega naught t minus phi n we can write. So what is Rn? Rn is equal to under root of An square plus Bn square. And what is phi n? Phi n is equal to tan inverse of Bn by An. See, all these values are going to hold for n greater than or equal to 1, because n is a value which is going from 1 to infinity, right? So n value should be greater than or equal to 1. Or simply we can say n not equal to 0 also we can write. N not equal to 0 means n greater than or equal to 1. Any of this same. So now what I will do? I will do some more simplification. See, basically I want to totally club these two things. I want to write from n is equal to 0. Then what I should? Suppose if I substitute n is equal to 0. Suppose if I substitute n is equal to 0, then what we are going to get? R0 is equal to under root of A naught square plus B naught square. But R naught is equal to A naught, right? R naught is equal to A naught. So from this we can say Bn is equal to 0. So therefore, since B naught is equal to 0, so we are going to assume B naught is equal to 0, then R naught is equal to A naught, R naught is equal to A naught. Then what is phi naught? In place of, in place of n I substitute 0, then what is B naught is equal to 0. So tan inverse of 0 by anything is 0. So tan inverse of 0 is equal to 0 degree. So 0 degree. So phi naught is equal to 0 degree. Then how I can write? I can write this total thing. I can write like this. I can write this total thing in a simple format, which is f of t is equal to sigma n is equal to 0 to infinity Rn cos of n omega naught t minus phi n. So all this thing I have written in a simple fashion, which is f of t is equal to sigma n is equal to 0 to infinity Rn cos of n omega naught t minus phi n. So I have written like this. So this is the way I have written. So if we expand, then what we are going to get? Suppose if we substitute n is equal to 0, then we are going to get R0 cos of, this is 0, cos of minus phi 0. So you can see phi minus cos of minus phi is nothing but plus cos only. So cos of phi 0, you know phi 0 is nothing but 0. So cos 0 is equal to 1 and R0 is nothing but A naught. So therefore we are going to get A naught only. So that's the reason I have clubbed all these things to a simple format, which is equal to. So now we can write all these things to a shortcut formula, which is equal to sigma n is equal to 0 to infinity Rn cos of n omega naught t minus phi n. Then what is the value of R naught? R naught is equal to A naught. And what is phi naught? So phi naught is equal to 0 degree. So this is what we have to keep in the mind. So R naught is equal to A naught and phi naught is equal to 0 degree. So this one. So basically, I think this is a this one I have simplified here, this one. So f of t is equal to A naught plus sigma n is equal to 1 to infinity A n cos n omega naught t plus B n sin n omega naught t. So I have made this into a very simplified fashion. Sigma n is equal to 0 to infinity Rn cos of n omega naught t minus phi n, where R naught is equal to A naught and phi naught is equal to 0, as you can see clearly from this one. So now this we have written. So now I want to find what are the Fourier series coefficients. What are the Fourier series coefficients? A naught, A n and B n are called as the Fourier series coefficients. So how to figure out these values, which is A naught is equal to 1 by t integration over t f of t dt, and A n is equal to 2 by t integration over dt f of t cos n omega naught t dt, and B n is equal to 2 by t integration over t f of t sin n omega naught t dt. Whereas omega naught is equal to 2 pi by t. So these are the Fourier series coefficients. So A naught is equal to 1 by t integration over the t f of t dt, and A n is equal to 2 by t integration over the t f of t cos n omega naught t dt, and B n is equal to 2 by t integration over the t f of t sin n omega naught t dt. So these formulas always you have to keep in mind. So a naught is nothing but 1 by t integration over the t f of t dt, and a n is equal to 2 by t integration over the t f of t cos omega naught t dt, and bn is equal to 2 by t integration over the t f of t sin omega naught t dt, and omega naught is equal to 2 pi by t. So these things always you have to keep in your mind. So these are the four series conditions. T is nothing but we are doing integration over the one time period. So a naught is equal to 1 by t integration over the t f of t dt, and a n is equal to 2 by t integration over the t f of t cos omega naught t, and b n is equal to 2 by t integration over the t f of t sin omega naught t. So how to remember? See, a n is having cos omega naught t. So a n is having cos omega naught t. Here b n is having sin omega naught t. So here also b n is having sin omega naught t. So finally, if I do summarize what I will tell, so listen carefully. Suppose if I am going to summarize, remember f of t is equal to a naught plus sigma n is equal to 1 to infinity a n cos n omega naught t plus b n sin n omega naught t. So this I have done in a simplified fashion is equal to sigma n is equal to 0 to up to infinity Rn cos of n omega naught t minus phi n, where Rn is equal to under root over an square plus bn square, and phi n is equal to tan inverse of bn by an. So and you have to remember r naught is equal to a naught, and phi naught is equal to 0 degree. So these things always you have to keep in mind. Now then what is the forward series? The coefficients a naught is equal to 1 by t integration over the t f of t dt. Then a n is equal to 2 by capital T integration over the t f of t cos n omega naught t dt, and bn is nothing but bn is equal to 2 by t integration over the t f of t sin n omega naught t dt. So these things always you have to keep in mind, then only we can solve. So finally f of t is equal to a naught plus sigma n is equal to 1 to infinity a n cos omega naught t plus b n sin omega naught t. So these are then simplified. Sigma n is equal to infinity Rn cos of omega naught t minus phi n, where Rn is equal to under root over n square plus bn square, and phi n is equal to tan inverse of bn by an, where n value is now from 0. So n value is from 0 to infinity. So n value is from 0 to infinity. But if you substitute n is equal to 0, then r naught is equal to a naught, because b naught is equal to 0, because we have assumed b naught is equal to 0. Then what is phi naught? As b naught is equal to 0, then what is phi naught? Phi naught is equal to 0 degree, and r naught is equal to a naught. So as we have assumed b naught is equal to 0, so therefore r naught is equal to a naught, and phi naught is equal to 0 degree, as you can see clearly. So this is what we have assumed. So for that n is equal to 0. So for we have assumed b naught is equal to 0, so therefore r naught is equal to a naught, and phi naught is equal to 0 degree. So if you want the Fourier series coefficients, then a naught is equal to 1 by t integration over the t f of t dt, and a n is equal to 2 by t integration over the t f of t cos omega naught t dt, and b n is equal to 2 by t integration over the t f of t sin omega naught t dt, where omega is called as a fundamental frequency. Its value is equal to 2 by t, where t is a fundamental time period. So these things always you have to keep in your mind. Let's go over the another concept, which is basically the exponential Fourier series. So up to now we have learned about the trigonometric Fourier series, but now we'll discuss about the exponential Fourier series. So listen carefully here. F of t is equal to sigma n is equal to minus m2 plus m3 cn into e to the power of jn omega naught t, whereas omega naught is equal to pi by t. I've already told you. See, as I've already told you, f of t we can represent in the terms of the exponential phasors. I've already told you. So any signal, any input signal, we can represent in the format of the exponential phasors. So just now we have discussed it. So f of t is equal to sigma n is equal to minus m plus m t cn into e to the power of jn omega naught t. So listen carefully. Just now we have discussed the inputs of the LTI system we can represent in the form of phasor, which is f of t is equal to sigma n is equal to minus m plus m plus cn e to the power of jn omega naught t. Whereas omega naught is nothing but 2 pi by t. Whereas omega naught is equal to 2 pi by t. 2 pi by capital T, as I already told you. omega naught is called as a fundamental frequency, which is equal to by capital T. Then what is Cn? Cn is nothing but, so basically this is called as the exponential Fourier series. So the periodic signal, periodic signal that we can represent in the format of the exponential Fourier series. So this is called as the f of t is basically periodic signal. F of t is basically periodic signal, right? So f of t is a periodic signal. So but periodic signal we can represent in the format of the exponential terms, which is sigma n is equal to minus f to plus infinity Cn e to the power of Jn omega naught t, whereas omega naught is equal to pi by t. So basically the signal f of t is a periodic signal. So we are going to represent in the format of exponential terms, which are sigma n is equal to minus f to plus infinity Cn e to the power of Jn omega naught t. So this one is same as the input. So where x of t, I have already told you f of t, sigma n is equal to minus f to plus infinity Cn e to the power of Jn omega naught t. There I have told, right? So here also same thing. F of t is a periodic signal that we are going to represent in the format of the phasor, which is sigma n is equal to minus f to plus infinity Cn e to the power of Jn omega naught t, and omega is equal to pi by t. It's basically periodic signal. Then what is Cn? The Cn I want to figure out. The formula is Cn is equal to 1 by t integration over the t f of t e to the power of, if it's a positive, take it here negative, that's it, minus Jn omega naught t dt, that's it. Here positive, take it negative. So therefore Cn is equal to 1 by t integration over the t f of t into the power of minus Jn omega naught t dt, where the value of n is lying from minus into plus infinity. The value of n is lying from minus into plus infinity. There, this point always you have to keep in your mind. So therefore we can say the value of n is lying from minus into plus infinity. So here the n is lying from minus into plus infinity. So Cn is also nothing but coefficients which are also going to lie from minus infinity plus infinity. So these things always you have to keep in your mind. So therefore finally I can say like this. So I can say like this, basically f of t is equal to sigma n is equal to minus f to plus infinity Cn e to the power of Jn omega naught t, where omega is equal to pi by t, and Cn is equal to 1 by t integration over the t f of t e to the power of minus j n omega naught t dt. So the value of n is lying from minus into plus infinity. So if you see clearly, the periodic signal we are going to represent in the form of the exponential terms. So the result is called exponential Fourier series. So f of t is equal to sigma n is equal to minus f plus Cn e to the power of Jn omega naught t, and omega is equal to pi by t, and Cn is equal to 1 by t integration over the t f of t e to the power of plus minus Jn omega naught t dt, and the value of n is lying from minus into plus infinity. So now if you see clearly, see I want to correlate Cn and Ans. So this I want to correlate the trigonometric Fourier series and this Fourier series, exponential Fourier series. I want to give some relation between them, the coefficients. So for the Fourier series there are coefficients are there, and for exponential, for the trigonometric Fourier series there are exponentials are there. There are constant, you can say this called the coefficients are there. So for the trigonometric Fourier series the coefficients are there, and for exponential Fourier series the coefficients are Cn. So I want to give some relation between them. So between them, which is Cn is nothing but An by 2 minus j Bn by 2, because you know e to the power of j theta. So what is e to the power of j theta? E to the power of j theta is equal to cos theta plus j sin theta. Here theta is nothing but minus n omega naught t. So just expand this one. So with theta is equal to minus n omega naught t. The substitute, if we expand, we are going to get finally in this format. Cn is equal to An by 2 minus j Bn by 2. An you know, An is nothing but this one. So An you know, this one. Same thing we are going to get like that. Same thing we are going to get like that only. So therefore you can see Cn is equal to An by 2 minus j Bn by 2. So listen carefully what I am trying to tell you. Here you know, e to the power of j theta you know, which is cos theta plus j sin theta. So here theta is equal to minus n omega naught t. So just keep this value, and if you expand, finally you are going to get like this. Cn is equal to An by 2 minus j Bn by 2. So I want to write, this is a rectangular format. So I want to write in terms of polar format. So which is under root over An by 2 whole square plus Bn by 2 whole square. So say, if you simplify, what you are going to get under root over An by 2 whole square plus Bn by 2 whole square is nothing but simply we are going to get under root over N square plus Bn square by 2 you are going to get. phase angle of, so here tan inverse means tan inverse of this value by this value. So minus you are going to get outside. So minus tan inverse of Bn by An. So simply, so tan inverse of this value coefficient by the kth coefficient. So minus is going to come outside. So minus tan inverse of Bn by An. So now in place of n, I will substitute minus n. Then what is going to happen? Listen carefully. Then C of minus n is nothing but An by 2 plus J Bn by 2 you are going to get here. So here what I am trying to tell you, see here C of n, this value you got. So suppose C of minus n means I am going to get here minus means here to become plus and remaining is same. So here minus means here plus, here minus means here will become plus, that's it, and remaining everything is same as it is. So you can see clearly C of minus n. So C of minus n. So C of n is nothing but this value, right? C of minus n means wherever n is there, p plus n by minus n, then you are going to get plus here. You are going to get plus. So here the power of j theta, cos theta, j sin theta, in you do expand, you are going to get like this. So what I am trying to tell you is very simple. C of n means this is the expression, right? C of minus n means wherever n is there, a plus n by minus n. So you are going to get plus here with the power of j n omega naught t. Then what is theta now? N omega naught t plus n omega naught t. This option, if you simplify, finally you are going to get like this: n by 2 plus j dn by 2. So this is a rectangular format. If you try to get in the polar format, we are going to get under 2 n square plus bn square by 2 at a phase angle of plus tan inverse of bn by an. So if you compare these two things, one is the conjugate of the other. So one is the conjugate of the other. So Cn conjugate is nothing but C minus n, or reverse is also true. Cn is nothing but C of minus n conjugate. So conjugate, both vice versa we can say. Cn conjugate is nothing but C of minus n, or Cn is nothing but C of minus n conjugate. Both are we can say conjugate of one another. One is the conjugate of the another. So this is the thing always you have to keep in your mind. So now what is C naught? So in place of n, if I substitute 0, then what I am going to get? C naught is equal to 1 by t. In place of n, I have substitute 0. So anything but 0 is nothing but e to the power of 0 is nothing but 1. So this value you are going to get 1. So 1 by t integration over t f of t into dt. So this value is nothing but 1 by t integration over t f of dt is nothing but it is a naught. So this is equal to a naught. So C naught is nothing but a naught. Then what is Cn? So I want to find Cn. Basically you can see this is under root over n square plus bn square is nothing but Rn. So just now we have seen under root over n square plus bn square is nothing but Rn. So Rn by 2. Here just I am going to write this one. See Cn is nothing but this value, right? So under root over n square plus bn square means Rn. So Rn by 2 at a phase angle of this tan inverse of bn by an is nothing but phi n. So minus phi n. So minus phi n. Here this value is nothing but phi n. So there is a minus plus minus phi n. So what is C of minus n? So this value is nothing but Rn by 2 at an angle of this value is phi n. So phi n. So this we have written here. So this thing, one is the complex conjugate of another. So whenever the complex conjugate, the order of cement, the probability of the angle will change. Positive means negative, negative means positive. So this is the thing always you have to keep in your mind. So now, if you see clearly, this Cn is nothing but it's a complex number. So it will have magnitude, it will have phase angle. So Cn is nothing but mod of Cn and the phase angle of Cn. What is the magnitude of Cn? Is Rn by 2. And what is phase angle of Cn? Which is minus phi n, as you can see clearly. And the value of n is lying from minus into plus infinity, minus into plus infinity. Suppose I want to, this is called the magnitude spectrum. So if I am taking over the magnitude part means it will become magnitude spectrum. If I take the phase angle means it will become phase angle spectrum. So this is called the magnitude spectrum of the Fourier series coefficients and the phase angle of the Fourier series coefficients in the exponential Fourier series. So this is a magnitude spectrum for the exponential Fourier series and is a phase angle spectrum for the exponential Fourier series. So this is nothing but magnitude, we can say the magnitude spectrum for the exponential Fourier series, and this is called as the phase angle spectrum for the exponential Fourier series. So magnitude of Cn I want to draw. Then the value of n is lying from minus n to plus infinity. So minus infinity. So all the integers we are going to take, all the integers, for all the things we are going to consider, and we are going to draw the magnitude. So you can see clearly the magnitudes are the same for plus 1 and plus 2. So for plus 1 and minus 1, the magnitude is same. So suppose if you substitute C1, then what you are going to get? Suppose if I substitute C1 means at n is equal to 1, I want to get C1 is nothing but R here to right here. So R1 by 2. So R1 by 2 at a phase angle of minus phi 1. And C of minus 1 is nothing but, in place of time I substitute here 1, then what I am going to get? R1 by 2 at an angle of phi 1, right? So if you see clearly what I can mention, the magnitude is same in both the things, but the only phase angle is reverse. So then what is the C1 here? So this is nothing but, let me draw here. So one picture, C1 is nothing but here R1 by 2, here R1 by 2, and this is also R1 by 2. So we can say this is an even. So always this is an even. Even means symmetric. It is symmetric. So even. So whatever this value, same thing we are going to get here. So this is an even signal. And if you draw the phase angle, I have already told you here, for this one, what is the phase angle? We can say plus phi 1. So plus phi 1. So plus phi 1, right? So this is a phi 1. Let me assume this is a phi 1. But for minus 1, what we are going to get? Minus phi 1. So therefore, minus phi 1. So you can say these are opposite of each other. Opposite. So sorry. For C1 is nothing but minus phi 1. So it will be down. So let me rub this one. So let me rub. This will be down and this will be a small correction here. So a small correction here. So let me rub this part. So let me down. So what is the C1? For C1, what is the angle? Minus phi 1. And for C of minus 1, what is the phase angle? Plus phi 1. So let me draw here. So let me draw here. So this will become minus phi 1. So this will become minus phi 1 and this will become plus phi 1. So you can see both are opposite of each other. So this is an odd function. So this is an odd function and this is an even function. So the magnitude spectrum is the even function and the phase angle spectrum is the odd function. So this is the thing always you have to keep in your mind. So finally, if I'm going to correlate the trigonometric Fourier series and the exponential Fourier series, then what I can say here, a f of t is equal to sigma n is equal to minus m to plus m to cn e to the power of jn omega naught t, and omega naught is equal to 2 pi by t. And here cn is equal to 1 by t integration over dt f of t e to the power of minus jn omega naught t dt. And the value of n is lying from minus m to plus infinity. Then what is cn? Cn is nothing but an by 2 minus j bn by 2. So if you simplify, we are going to get under root of an square plus bn square by 2 at a phase angle of minus tan inverse of bn by an. So if you want C of minus n, C of minus n is equal to Pound's constant of this one, an by 2 plus j bn by 2 is equal to under root of an square plus bn square by 2 at a phase angle of tan inverse of bn by an. So one is the conjugate of the other. So Cn conjugate is C of minus n, or C of n is the conjugate of the C of minus n. So then what is C naught? So if you substitute n is equal to 0, and if you simplify, we are going to get C naught is equal to a naught we are going to get. Then what is Cn? Cn is nothing but, this is Rn by 2 at an angle of minus phi n, and C of minus n is equal to Rn by 2 at an angle of phi n. So this is what I am trying to tell you. So for the exponential Fourier series coefficient will have the magnitude as the phase angle. So the magnitude spectrum is always an even spectrum, and the phase angle spectrum is always an odd spectrum, as you can see clearly here. So these things always you have to keep in your mind. So finally, let me write the formula here. So let me write here, f of t is equal to sigma n is equal to minus infinity to plus infinity cn e to the power of jn omega naught t dt. Here omega naught is, sorry, there is no dt, so omega naught is equal to pi by t. And what is Fourier series coefficient? Exponential Fourier series coefficient cn is equal to 1 by t integration over dt f of t into e to the power of replacement will become minus n omega naught t into dt. And if you expand, I already told you cn is nothing but an by 2 minus j bn by 2. So if you simplify, we are going to get like this, which is Rn by 2 at an angle of minus phi n. And the C of minus n is nothing but an by 2 plus j bn by 2. So it is nothing but Rn by 2 at an angle of plus phi n. And one is the conjugate of the other. So therefore we can say C of n conjugate is C of minus n, or Cn is equal to the conjugate of the C of minus n. So anything one is the conjugate of the other. Definitely Fourier series coefficient, exponential Fourier series coefficient will have the magnitude and the phase angle. So the magnitude spectrum is always an even spectrum, and the phase angle spectrum is always an odd spectrum. So these things always you have to keep in your mind. So this is all about this exponential Fourier series. So these always you have to keep in your mind. Basically, let me do the revision of the trigonometric Fourier series and the exponential Fourier series. So in the case of trigonometric Fourier series, any periodic signal can be written as f of t is equal to naught plus sigma n is equal to 1 to infinity an cos n omega naught t plus bn sin n omega naught t. So this you can write like this, please, which is equal to sigma n is equal to infinity rn cos of n omega naught t minus phi n. And I already told you rn is nothing but under root over n square plus bn square, and phi n is equal to tan inverse of bn by an. The n value is ranging from 0 to infinity. So we have to assume b0 is equal to 0. Then what is going to happen when n is equal to 0? So r0 we are going to get, which is under root over a0 square plus b0 square. b0 is equal to 0. So therefore r0 is equal to a0. And if we substitute b0 is equal to 0, then phi0 is equal to 0 degree. Then what's the value of a0? a0 is equal to 1 by t into the t f of t dt, and an is equal to 2 by t into the t f of t cos of n omega naught t dt, and bn is equal to 2 by t into the t f of t sin n omega naught t dt. So these are the Fourier series coefficients. Now let's go for the exponential Fourier series. Here f of t, the periodic signal can be written as the f of t is equal to sigma n is equal to minus n to plus n of t cn e to the power of jn omega naught t. So then what's the Fourier, the exponential Fourier series coefficient? Cn is equal to 1 by t into the t f of t. Here plus means here minus jn omega naught t dt. Here omega is equal to 2 by t in both the cases. So if we expand this one, we are going to get finally Cn is equal to an by 2 minus j bn by 2. So this is the rectangular format. If you convert to polar format, we are going to get under root over n square plus bn square by 2 at an angle of at a phase angle of minus sin inverse of bn by an. So this value is nothing but rn, and this value is equal to phi n. So therefore rn by 2 at an angle of minus phi n. Similarly, c of minus n, in place of n substitute minus n, if we simplify, we are going to get an by 2 plus j bn by 2, which is equal to under root over n square plus bn square by 2 at a phase angle of plus tan inverse of bn by an. So this is nothing but rn. So rn by 2 at a phase angle of, and this is phi n. So plus phi n. So we can say one is a complex conjugate of the another. So Cn is a conjugate of c of minus n, or c of minus n is the conjugate of the c of n. And what is c of in place of n if we substitute 0, and if we simplify, we are going to get its value is equal to a0 we are going to get. So this is the relation. So you have to understand this is the trigonometric Fourier series and this is the exponential Fourier series. These two things always you have to keep in your mind, and their relation also you have to keep in your mind. So now let's go for the other concept, which is it is relating the real Fourier series and the exponential Fourier series expressions to an example. So now I am going to basically relate the real Fourier series and the exponential Fourier series expressions through one of the next example. So basically I am going to take one example in that I am going to tell you, I am going to show you the expression of the Fourier series in the trigonometric version as well as in the exponential version. Listen carefully. I am going to take some example, periodic signal example, and then I am going to write the expressions for the signal in both the trigonometric as well as the exponential. So listen carefully. So this is a periodic signal. I have taken f of t. It is an impulse waveform, a periodic impulse waveform I have taken here. So it is having a period of time period of t. So it is having a time period of t. So it is basically a periodic signal, which is basically an impulse. So now I want to write for the signal, I want to write what is the expression in the trigonometric domain as well as the exponential domain I want to write. Then you know how to represent this f of t. The general representation, you know, f of t is equal to sigma k is equal to minus n to plus n t L2 of t minus kt. So this is the general way of writing this f of t. F of t is equal to sigma k is equal to minus n to plus n L2 of t minus kt, where omega is equal to 2 pi by t, because the fundamental time period is t. So the fundamental frequency is equal to omega is equal to 2 pi by t. So now basically now first thing is I want to find what is the the exponential Fourier series coefficient Cn I want to find it. So Cn formula, you know, Cn is equal to 1 by t integration over the one time period into f of t into e to the power of minus jn omega naught t dt. So this is the formula, you know, integration over the one time period. So one time period means you can take any time period. So it will go from minus t by 2 to plus t by 2 means from here to here I will go. You can go for any one time period. So I will go between these two regions. I am going to go from minus t by 2 to plus t by 2. Between these two things I am going to go. So integration over the minus t by 2 to plus t by 2. So if you see clearly, so between this time period, what I can say, it is basically an impulse. So it is basically an impulse, right? So f of t is going to become impulse. So in this time period, what is f of t? F of t is delta of t. So this is going to come outside, because here t is equal to 0 if you substitute. So if it's substitute t is equal to 0 in this one, then we are going to get its value is equal to 1. And the integration of the impulse is nothing but its value is equal to 1. So therefore 1 to 1 is equal to 1. So 1 into 1 by t is nothing but 1 by t. So therefore I can say that, as I already told you, an important formula, integration over the sum minus f2 plus f2t delta of t minus t naught into f of t is how much? It is equal to f of t naught. So this concept I have already told you. So therefore from this concept only we have got this value. So during this period that t naught is equal to 0. So in place of f, t is after t naught is equal to 0. So therefore we are going to get, so here t naught is equal to 0, right? So because the f of t is T2 of t, so t naught is equal to 0. So this is nothing but f of t. So in place of t, a plus t naught, so t naught is equal to 0. But if we substitute, we are going to get its value is equal to 1. So 1 to 1 by t is something like 1 by t. So we are going to get the Cn is equal to 1 by t, you are going to get. And you know the exponential Fourier series expression. What is the sign expression? F of t is equal to sigma n is equal to minus n plus Cn with the power of j n omega naught t. So this one just now we have discussed, right? And what is Cn? Cn is nothing but 1 by t. Just now we have figured out Cn is nothing but 1 by t. So we can take it outside because Cn is a 1 by t. So t is a constant, means 1 by t is also constant. So for a given signal, t is constant, so 1 by t is also constant. So take it outside because it's independent of n. It is independent of n, right? So take it outside. So 1 by t sigma n is equal to minus n to plus t with the power of j n omega naught t. So this is the exponential Fourier series for this expression. So this is the exponential Fourier series early solution for this signal. Then you know what is C naught? C naught, you know, C naught is nothing but A naught. Just now we have discussed. C naught is nothing but A naught. So C naught is nothing but basically A naught. So A naught is nothing but C naught is equal to A naught, right? Then what is C naught here? Here Cn is equal to 1 by 2. So with respect to the value of n, its value is always equal to 1 by 2 only. So if you substitute n is equal to 0 also, its value is equal to 1 by 2. If substitute n is equal to 1 also, its value is equal to 1 by 2. If you substitute n is minus 1 also, its value is equal to 1 by 2. So therefore, what is C naught? C naught is equal to 1 by t. So then, but C naught is equal to A naught. So A naught is also equal to 1 by t. Then what is Cn? Cn formula, you know, what is Cn? Cn is nothing but an by 2 minus j dn by 2. But Cn is equal to 1 by t only. No matter what are the value of n, from minus n to plus n, its value is always equal to 1 by t. So its value is equal to 1 by t. So by comparing, what we can say, the imaginary part is equal to 0, means Vn is equal to 0. And what is the real part? An by 2 is equal to 1 by t. So we simplify n is equal to 2 by t. So therefore, an is equal to 2 by t you are going to get, and bn you are going to get 0. Because by comparing, we can say that the exponential part is equal to 0, means Vn is equal to 0. And if you come to the real part, then we are going to get an by 2 is equal to 1 by t. So n is equal to 2 by t. So we can get Vn is equal to 0 and an is equal to 2 by t. And so from all these things, what are the data we have got? So from all this, what the data we got? C naught is equal to 1 by t, and n is equal to 2 by t, and Vn is equal to 0. All these things we have got from this one. So now what is the assigned expression of the trigonometric Fourier series? F of t is equal to A naught plus sigma, n is equal to 1 to infinity, an cos n omega naught t plus bn, sin n omega naught t. So this is the standard expression. So we know all these values, right? A naught is nothing but 1 by 2, or substitute here. An is nothing but 2 by t, so I have substituted here 2 by t. And Bn is nothing but 0, so this value will become 0. So only this term and this term is going to get finally. So therefore, f of t is equal to 1 by t plus sigma n is equal to 1 to infinity 2 by t cos of n omega naught t. So this is the real Fourier series expression. So by this example, what we have did, so with the help of this example, we have obtained the Fourier series, the exponential Fourier series expression as well as the trigonometric Fourier series expression also. So if you know one thing, you can get the other thing by the relations only. So if you know one thing, you can get the other thing with the help of the relations. So this is the point always you have to keep in your mind. So initially we have to know the value of Cn, and Cn value we got 1 by t. So Cn is nothing but from anyone is varying from minus infinity to plus infinity. Its value is always equal to 1 by t only. So 1 by t only. So therefore we can say that. So from this we can get the value of A naught, An and Bn. So we have kept this value in the standard Fourier series expression, trigonometric Fourier series expression. So we got the trigonometric Fourier series expression also we got. So finally, at the end of this example, for a given signal, we have obtained the exponential Fourier series, and also we have obtained the expression for the trigonometric Fourier series. So these things always you have to keep in your mind.